So yes, you are welcome to the last session of our day 2 summer school. This is the last session, and we're going to be continuing with machine learning and deep learning. And after that, we move into NLP, natural language processing. So I will call on our brother again, Bro Roland, to take over from there. Thank you, brother.
Hello. Wow, what a morning I'm having here. Welcome back, everyone, and I hope you guys had some time to and recalibrate. So um let's just go back a bit a few steps back. We've been talking about machine learning. The first types of machine learning. We've looked at supervised learning extensively, I would say. We didn't even talk about unsupervised learning. We looked at supervised learning, and we said one thing that stands out for supervised learning is that it deals with labeled data. And there are two types of supervised learning. There is the regression side, and there is the classification side. In the regression side, we are trying to predict continuous variables, while in the classification side, we are trying to predict categories. So an example of a regression use case would be to predict house prices, right? If you want to predict the price of house in a given neighborhood, you want to predict the price of houses, you want to predict the weights of a particular class of students. We want to predict the BMI of a given group of patients, and so many other examples that we could think of. As long as it involves predicting a continuous variable, a numerical variable, continuous. Let's stick with continuous. The other types that would deal with numerical and other ordinal regression and other. So want to predict continuous variable, linear regression. Regression is our go-to. And for categories, we mentioned that we want to predict categories, true or false. Usually the outcome for classification model is usually binary. Like, yeah, I don't think I mentioned that. The outcome, the target, is usually to predict a binary class. Or in some cases, it could be multinomial, where you're predicting more than two classes. When you start predicting more than two classes, it's multinomial. So when you're predicting one class, two classes, binary. So for example, somebody is diseased or disease-free, somebody is African or is black or is Caucasian, someone is likely to buy or not buy. A given email is likely to be spam or not or not. A customer is going to likely come back or not. So those are categorical use cases. And we mentioned that in both groups, there are specialized machine learning algorithms that are specific to each group. They are specific to regression, and they are specific to classification. Two of those groups, those specialized models are the linear regression model and the logistic regression model. The linear regression model is is used primarily to predict continuous variable. There are several nuances behind the linear regression model. You have the assumptions, and you're looking at, okay, it is first of all, it's normally distributed. The independence of errors, the variance is constant. You want to look at all those, and also want to evaluate the performance of your linear regression model. We identify a couple of metrics to evaluate the performance of a linear regression model, and we said P of those is the R squared, coefficient of variation, as we call it, the root mean square error. So we are saying what is the minimum error allowable by this model. So for the root mean square error or the mean square error, which is the average error acceptable. Now, why do we use roots? We square root it is a unit that we could as across board. But the lower the root mean square error, the better the performance of the linear regression model. The higher the R squared, the better the performance. So for the linear regression model, you want to check out for this too. And you also want to look at your residual plots. We're not going to do linear regression, unfortunately. But these are things you want to look out for to ensure that your model is performing optimally. Now, we also highlight, let me touch the classification part. The specialized model for it is the logistic regression model. So it's either a 1 or a 0. So you're essentially predicting probability. Probability can only take the limit between 1 and 0. So that's the boundary. 1, 0, 0, 1, rather. You cannot go beyond that. So if it's a probability, it's either at the extreme end of 1 or at the extreme end of 0. So you're predicting a class, a spam, not a spam. The customer is going to return or not. The customer is going to churn or not. So that's what we use the logistic regression model for. Now, the interesting thing is for the classification model, almost all the evaluation metrics are the same, right? You use accuracy, precision, recall, F1, rock curve for logistic regression. You can still use the same metrics for any other any other model that you want to use that has to do with a classification problem. Any model that you want to use classification problem, you use the same set of metrics, but it's always advisable to combine multiple metrics just to ensure a balanced view of the performance of the model. Same with regression, same set of metrics. R square is only for linear regression, but there are mean square error, there are root mean square error that you can use also to evaluate performance of a regression problem. What else did we discuss? So we discussed about, we went further to discuss about deep learning a bit, and we said why was it important? Because complex problem requires complex solution, and that's where deep learning comes in. You're trying to understand if you're trying to classify between images, and we got to understand that images are made up of pixels. Classical machine learning model will not be able to handle such high dimensional data. So step in deep learning. And what's the idea behind deep learning? The idea is simple. Take the human brain, for instance. It's a connection of nodes to form a particular to result in a particular outcome. We made a classical example of I've even been in this meeting. You take information with your eyes, your brain processes it and tells you what you're currently doing or what you're currently experiencing. Same with deep learning. You take the input, then you have the hidden layer. The hidden layer is feed forward and back propagation. Then you have an output node. Now, one of the drawbacks we mentioned about deep learning is that it's a black box model. Oftentimes, you don't know what's going on behind the scene, right? That's why there's always advice to err on the side of caution when developing such models. You want to be sure that you're able to explain what is going on behind the scene. And when you do, it makes the whole process easier. So if at all you want to use it, be sure to be able to explain what happens. It's not like, okay, because it's black box, don't use it now. The same, be sure to tell whosoever you're explaining the model to, what went into it, how it, in fact, these days, there are even softwares that visualizes how the model generates, interacts with the hidden layers and generates its output. So good for science and good for us as well. So we mentioned that it's the same. It can either solve the thing about deep learning is it can either solve a regression or a classification problem. I don't think I mentioned that. So it can solve both a regression and a classification problem. So if that's something you're interested in, yeah, you can also solve it with deep learning. But the industry advice is always start with a simple solution. Always start with a simple solution. Reason being that you want to build on a simple solution. Because if you go from a simple, you begin by going to a complex solution, you don't know, you won't be able to understand, okay, why does it perform the way it performs? So building up like a stepwise process, building from a simple solution to a complex solution is always advised. That's an industry norm to build from a simple solution. Another industry advice is on data. Good data make good models, right? If your data is clean, you now understand that the challenge or what you're currently experiencing is fine-tuning the model performance. That's what involves hyperparameter tuning. The goal is to optimize your model to produce the best result at all times. So that's why we fine-tune the hyperparameters in our models. All right. And I'm just trying to like run a quick recap of what we did. So I'll give room for anyone who wishes to ask any question. Then we go to the last section of the hands-on. So if you need to set up your computer, set up your PC, set up your monitor, just do it. So we go through it together. So yeah, final thoughts. It's simple. Machine learning is simple, it's interpretable, very interpretable. At all times, you want to be able to interpret the results you're getting. You want to be able to interpret why you are getting that result. Why? What is important to this model? You know, in I experience somewhere at work where we're trying to explain, given the set of features that went into developing our model, which was most important, and we want to cost it. How much will it cost us if we drop that feature from the model? All right. Interpretability is like key in the ML world. You want to always interpret what's going behind the scene. Your chat GPT that you use, the developers of the model had to interpret what went into training the model. And that's why there are kind of like class actions around AI, sort of, and there are ethical concerns around it because you always want to understand what went into developing the model. I think the Meta or Llama model has close to about 65 billion parameters, that was used to develop the model. So in that 65, they have to explain what each of the 65 does. You don't just build it in a vacuum and like take and use, no. So it has its good part because every machine learning model or deep learning model can do maximum good and maximum evil. It requires interpretability. And also another concern is fairness. There are certain model that will be biased towards certain groups of people, you know. So let's take for example, the model that predicts if someone should get a loan or not have been found to be biased towards people of black ethnic groups because the model was trained primarily with Caucasians. So it's always biased towards black ethnic groups. So in that case, fairness is not established. So what that model needed, or what research showed, was that the model should be retrained that such that it covers the diverse populations that it is to be used, is applicable to. So you always want to consider fairness in your development, build because the result is nice, is cool, your true positives are okay, you have a good balance between your true positives and true negatives. So true positive is simply your model was able to predict the positive class. True negative, your model was able to predict the true negative class. So you have a good balance between the two. Fine. But also ensure that it is fair to everyone that will be using the model. So one final thought is build, test, and iterate. So when you build this model, you have to test it. That's why we also mentioned that you have to split your data into train and test set. You use the train set to train the model, you use the test set to evaluate the performance of the model. And the rule of thumb is to use either 80-20, 70-30, 65-45, 75-25 as the case. So that's why it ended with iterate. You keep iterating, you keep testing until you get an acceptable performance. You find a balance, right? It's not discriminating against one group. It's not overexcited. It's not overfitting. It's not underfitting. It's optimal. Always, when it comes to machine learning model, we are finding the optimal solution between overfitting, underfitting. What's the sweet spot in the middle? That's what we are always finding, the optimal solution. Yeah, I think anyone are you supposed to be screen sharing? Can you see my screen? I'm not sure. Yeah, plus or minus if you can see. Plus if you can see. Someone is asking. I'm not sure what you meant, brother. Okay, good. So at this point, if you have any question, just drop it in the chat, or I mean career question, learning question, or what we've just discussed. Let's take that for a few minutes, then we'll go back to practical. And yeah, just sharing a bit of resources, hands-on ML, deep learning with Python, good books, Coursera. I'm currently also taking a course on Coursera right now. So learning, the thing is, in this field, learning never stops. So you keep learning. It's because something happens every day, something changes, So you just keep learning. So we learn all the time. Yes, I'm not pretty sure it can. It has its limits. So if you want to handle big data, you have to pay for it to use Scholar. Yeah, you have to pay for it. I think I did a project that would take news contents, news articles, and it will tell you what the news is about. And to summarize the news for you and tell you, okay, this news is about technology, or this news is about sports, or is about finance, it's about policy. So I ran into memory issue. So if you want to use it, you have to pay for more compute resources. In the industry, people use this AWS, Databricks. I use Databricks. They use the AWS. They use Microsoft Azure. So that's what people use in the industry. There's Google, what's it called now? Google is not Colab, but see. So Google has their own
Is it Google
platform.
Cloud Platform?
Yeah, Google Cloud Platform. Thank you. Google Platform. That's so Colab is mostly for learning. So you have Google Cloud Platform. It's all encompassing machine learning, deep learning, agents, and all that. Almost all the industry platform, Databricks, AWS, Google Colab, Google Cloud rather. It's all encompassed for ML and this deep learning and the likes. On how to upload CSV file into Google Colab for analysis. I did not get that explained very well. So the thing is this, if you're listening, you have to have uploaded your CSV file into your drive. So you have to, how do we call it? How did I call it the last time? Have to connect to your drive, your Google Drive that has the Google Colab account and upload the file to that drive. When you do that, the rest is just finding the link to the CSV file and it will upload. If you try it, it doesn't work, let us know, would help you, but that's a simple solution you can provide. So any other question, guys? Ask question. We still have I want the rest of the class to be that you're the one running it. So that's why I'm interested in asking questions before we jump into that. If so Google Colab is like a platform for you learned this morning about Jupyter notebooks. So Google Colab is kind of time-based. Yeah. Can Google Drive work with Jupyter Notebook? I haven't personally tried it, but that would be something interesting though. I haven't tried it. Yeah. But it should, yeah. It should. It should. You just need an API to connect to the Google Drive. It should. Because if you can collect an online database, you can definitely connect to Google Drive. Yeah. This 2-day section is really brief. Please, where can you link someone who wants to elaborate more on this? Yes, so the thing is this, I'm sure someone will speak more on this, but it's not exhaustive, but the what I want you to pick from this is you learn from here, you learn from there, you learn from there. You know how we say in Africa, like what do they call streams is what makes a river. Streams from different places come together to make a river. So like learn what you can take from here. Now that I open the room for questions, right? Learn what you can take from here. Build on it. I didn't, it was during my master's degree that I went into machine learning and deep learning properly. I learned it. I taught myself how to code, right? I just taught myself how to code. I saw people doing it and I taught myself how to do it. Right? You just keep going. You just keep, yeah, it's good for exposure. Now you know that there's something called logistic regression if you've never heard of it before, or random forest if you've never heard of it. Now you like you have a way now to now go and look at them in a broader sense. I haven't used Google Colab between Google Colab and Accountant using VS Code. Which one would you see is the best? I like VS Code. I like VS Code. It's not really about the best. It's about preference. Where do you code faster? And now no one is expecting you to write all the codes from the top of your head. So every company is working on agents to help the engineers perform better. So one platform that integrates all these resources is VS Code. Like they have extensions for most things, for most co-pilots, code assistance. They have most extensions for it. So I would always say For a start, use Cola, Anaconda or Jupyter Notebook for a start. So once you feel comfortable, because what it does is this, Jupyter Notebook makes you think. You don't know the solution, so it makes you think about the solution. Yes, VSC is more interactive than others. Yeah. But Jupyter Notebook makes you think about the solution. It makes you research about the solution. VS is likely going to help you get the solution quick. So when you're still at the process of learning, get Can I call you back? I'm in a class. So like start with Jupyter Notebook. Right. When you're learning, start with it. Yeah. I would advise you to start with it. But if you want to be like, oh, I don't need it, good for VS Code, you can install all the code assistance you need. You shoot as fast as possible to the moon. Right. And please take courses. YouTube should be your best friend. Yeah, you saw my browser, like so many YouTube tabs. Those guys. I still learn. I would have been studying this night, only that I got back from church late. So I just okay for this night, let's sleep. Because I have a class this morning, so I needed all the rest I could get. So studying, study. You will never get all the results in one place. You never get all the results in one place. So that's why you start. I start for a course. They're calling medium. So like, okay, let them rest for now. How can I link what I learned yesterday about Python and supervised learning? So if you have learned about NumPy and pandas yesterday, if you learned how to write code, I'm not sure what the topic was. I was at work yesterday, so I just breezed in and breezed out. But whatever you learned yesterday, how to write simple codes, how to write for loops, how to write functions, you will need it. I won't tell you where, but you will need it. Is to write functions for your own ML models. You will need to write functions for your own deep learning models. You will need to look through data. You see that? So you would when you start doing practicing, you will see the connection. On the baby knowledge I have, okay, with all that we have been taught. May I ask, I missed out on the link for the attendance rate. Yeah, please, you can share the link for the attendance. Someone is asking, VSC, I think it does. Yeah, I think it does. You have to install, it does, yeah. You have to install the latex extension. Install the latex extension. Like I said, it's all purpose use. So like configurations, different code configurations that you want with VSC, you can always get is packaged as an extension. So just install the extension and you're good to go. Yep. So any more question? Anyone thinking about going deep into machine learning, deep learning? Yeah, I tell you, it's an interesting field. And the thing is this, right? I know with the advance of AI and everything, sometimes you get scared like, is this even still relevant? Yes. Building from it. The thing is, don't get stuck on thinking, okay, I have this, I'm okay. This build on whatsoever you've learned. Well, the post model depends on what's on your metrics. Let's go back a bit. We looked at the regression and the classification um, types of supervised learning. The regression side of things has different metrics: R square, mean square, or root mean square, or mean absolute difference, right? The classification have accuracy, precision, recall, rock call, rock AUC. They all have their drawbacks. They all have their importance. Trying to work on imbalanced data, you want to look at precision and recall. Right? So they all have their importance. So it depends on the problem, the solution you're trying to interpret, and the business importance of the model. And also, you want to look out for what my model did during training, what is it doing during testing. If there's like a wild difference between the two, your model is not doing good. So let's see if you test the training accuracy, you're getting 8%. You now test the test using the test sets, you are getting 40% or 60%. Your model is overfitting. You have training data, so you have to fine-tune it again. I can't even do without learning it to a table size as spreadsheet. Look at requires it. I mean, I'm on LinkedIn. We are all on LinkedIn. The thing is this. One thing I observed is I too follow mentors, right? I too follow people when you need to ask question about what is going on. I follow them. I send them a message. I want to know this. Could you point me to a platform or a resource that I could use for this? That's the way you learn. Like in this world now, I don't think like the people have that time to like sit you down and feed you like it used to be. But if you're always asking like, okay, point me in a direction, they would always have the opportunity to talk you through it. Okay, what's the difference between Python? Python is the programming language. PyTorch is a library for deep learning. The popular library for deep learning, sorry I didn't mention, the popular library for deep learning is Keras and TensorFlow, but there's also PyTorch that's used for deep learning. So PyTorch is a library that's used for deep learning. Okay, so I think I don't think there's more question. AI is robotic. Robotic is AI, brother. Yeah. So yeah, I like making that joke too. AI is robotic. Robotic is AI. The two can't separate each other, right? GitHub repository. So let me answer the first. One works off each other. You use AI to automate to make your robot work better, right? So you see that your robot is able to decide, okay, your self-driving car, right? People have all seen Teslas and self-driving cars. So how is the Tesla car is essentially a robot? So how is it able to know how to park itself? How is it able to detect object on the road and avoid it? It's a deep learning model. The model was trained to detect objects in real time. Then that model was installed on a chip and installed into the car software. So and connect say, like Internet of Things. We can go the distance on this Internet of Things. So the model was trained, install it on a chip, install it into the software of the model of the car, and every hardware fits from that software to perform the functions that it needs to perform. That's why I said AI and robotics, they feed off each other. Robotics brings the beauty out of AI, right? GitHub. So GitHub is an online platform where we store our codes. All right. It's essentially used for version control and for collaboration. I think yesterday I had to submit a code to on my organization's GitHub so some of my colleagues can work on the code as well. So it's used for collaboration, it's used for sharing, it's used for versioning. So let's say you worked on a project today, or there are changes you need to make, you make those changes, you update it. GitHub will still keep the last version, but it will show you the update that you currently made, and it will merge everything. So essentially, you need to know, I think there are a couple of, I think 5 functions: git clone, git add, git commit, git push. Yeah, okay. Git clone, git add, git stage, git commit, git push. So those 5 functions, if you know how to use them, git branch is there. Git checkout is when you want to switch between branch. Git merge if you want to merge 2 branches together. I think that's about 7. If you know those functions, you're good with GitHub. And you learned this morning about bash scripting. So in my own device, in my own system, I use that bash for version controlling. So I write a code, I want to update it on my GitHub, I use bash to do it. How did I learn it? With YouTube. As I learned. I wasn't taught. I learned it. So guys, you can learn everything. I take it from me, you can learn everything. Between PyTorch and Tensor, which one is better for deep learning? Bro, TensorFlow is more popular. But I've heard some people say PyTorch is actually very in-depth, very adept at at what it does. But if you're going to share your code to a general audience, your deep learning code to a general audience, I would advise you use TensorFlow, because everyone that attends the deep learning class is going to first use TensorFlow and Keras. Yeah. Okay. I think we made some good strides here, everyone. So sure. So back to base. We stopped at, okay, so I need to reconnect here. Welcome back. It was good talking to everyone. And yeah, fast a bit. So I can also meet up with my today's commitments. So we talked about the various machine learning models that exist, right? And we talked about that there are already open source libraries that are used to develop machine learning models. You guys have already learned about libraries such as pandas and NumPy that are used for data manipulation and wrangling and pre-processing and the likes. We learned about those types. The important libraries for machine learning is scikit-learn. You use scikit-learn for everything machine learning. So NumPy and pandas, data manipulation, scikit-learn, machine learning. Look, if you will you know all the functions? No. But as you continue to explore what scikit-learn is about, I don't know if you can see it, but this is the book I was talking about, right? It's a very great book. So get it, and you will thank me later. So as you continue to explore, you will learn more functions, more libraries, but primarily scikit-learn is used for machine learning models, for developing machine learning models. So first thing first, before you begin, you've identified your data. So for this case, we want to predict diabetes. What is our problem? We want to predict diabetes. The patient is likely going to have diabetes based on their characteristics, BMI, diabetes predisposition, age, and several other factors. So we want to say, okay, what will it take? What will be responsible? The name of the book is Hands-on Machine Learning with Scikit-learn and TensorFlow. I'm not their agent. I'm not selling the book. So I think the author is Aurélien Goku. I think it's French. Guérin. Is it French or Aurélien? Yeah, it's French. Hands-on machine learning with Python and scikit-learn and TensorFlow. Great book. I think I finish reading it sometime. I always still go back to it for reference. Like so, learning never stops from here. So what do you start with? You import your libraries. So for this project, for this section, we've decided to import 3 libraries. So let's see. Let me do something. You all can you see my screen? There's a plus or minus if you can see it. Okay, great. So look at what we've done. These 2 libraries, data manipulation. I know. So let me zoom in. Okay. So this library is for data manipulation or importing your data for manipulating it. It's 2 libraries. It's for data visualization. So you want to visualize your result because a stakeholder don't really want to see numbers. They just want to see visuals. That helps them make better informed decisions. So you always want to visualize your results. All right. Then machine learning. Model development. See, 3 groups of libraries. There are other types of library. As you explore, you will get to know them. But essentially, this is what you need to start in machine learning model. Scikit-learn. From scikit, in fact, the good thing is this. Once you say from scikit-learn dot, it will give you so many options, right? What do you want to do? You just think about it. What do I want to do? Support vector machine model that I want to create a pipeline, metrics, discriminant analysis, pre-processing, Gaussian naive Bayes. This is also an ML model type. Clustering, I want to do imputation. So manifolds, ensemble learning. What do you want to do? Model selection, linear model is there. So what I've done here is I want to use model selection. What function am I looking for? Pinterest. All right. Print split function. Again, linear model. What type of linear model am I looking for? Logistic regression. Says this class implements regularized logistic regression using the linear library. They are telling you the types of library uses. It's applied by the but can handle both dense and sparse impute, use C ordered arrays or CSR metrics, blah 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 blah. Elasticnet, it's telling you what the model can do. So just by playing around with it, you have even more information, right? I know you're interested in going deep. But I would say you can actually go a lot deeper with the foundation you have now. You've learned how to code, trying to understand how machine learning works. So you're on the right track, right? So I wanted to spend some time on the theory, but yeah. So standard scalar, right? Standard scalar, this is for splitting the data. Split the data. Remember, one of the things we said was you have to split the data set into training and testing sets. Then another thing we said was you have to what, scale it in case they are scale your data. In case they are different scales, right? One is measured in thousands, one is measured in pounds, one is measured in kgs. So you want them to be on the same scale. That's why you scale. So here is a function that calls your model. And in this case, logistic regression. All right. Function that we are saving it to an object. And lastly, we import what? Evaluation metrics. Guys, did we see that what we've simply done is we have listed the process that we saw in the slide. With this, we have listed that pre-processing, that process that we outlined in this slide. Data manipulation, data visualization, machine learning model development, evaluation metrics. We listed all of them. So the next step is how do you load your data? So for the person that asked how to load your data on, if you want, you would once you have it on here, you just upload it to current section, choose the file where it is located, and voila, you import, use the API and you import it and it works. So I've done it before. I just wouldn't want to go down there. So the data we want to use is here. Is on this GitHub page. All right. Want to use on this GitHub page. Let's see. So this is the data we want to use. Right. So we copied it. These are the columns. So we read it as a CSV file. We downloaded, we asked it to be saved as a CSV file. So we read pd.read. For the person that was asking, how do you read a CSV file? pd.read_CSV. Right. Primarily, most data you're likely going to be working with for the large part of your lives, and for the large part of my lives I've worked with, are going to be tabular data, even text data, even if you're developing AI models like RAG and all that, you still index your documents. In a way, is in a tabular form, but it's not in a tabular form. All right. So most data set you're going to be working with is going to be on tabular. We take a tabular format. So what do? You import the CSV file, the names is the column names you've called it. During my own break, I went to the gym, so I'm feeling a bit exhausted. So you import your data sets, and yeah, that's it. Error PD not found. So does anyone know why PD is not found? Anyone want to put in the chat why I have this error? Quick. Let's see if anyone is following. Because part of your job as a data scientist, or you're going to be a data scientist, is your ability to know an error The ability to diagnose an error and find a solution to it. Don't just blindly copy and paste always to ChatGPT. It will give you an answer, but try to understand, okay, this is why this is happening. Great, great. I should have imported pandas. Should have imported the pandas library. So that's why I am having an error. So even when you go for interview question, when you go for interview, part of your interview question might be to try to understand how you handle error, how you treat errors when you come across them. Do you just copy and paste, or do you try to find out what caused the error? Root cause analysis is always a good way. So you see, immediately I imported my library, my pandas library folder. I have my data set. All right. So the next step for me is to clean the data. The next step in the analysis process is to clean the data. Remove missing values, remove zeros if there shouldn't be zeros. I treat them. So I can treat them by replacing the zeros with the average of all other values, or I can simply remove them. That's one way you treat missing values. All right. I can fill them or I can remove them. I can either fill them with the mean or the median or the mode. I'll leave that up to you to explore. So what have I done here? Zero features, number of zeros before cleaning. So glucose have 5 zeros. Blood pressure, 35. Skin thickness, 227. So but I don't need zero in my model because it's going to affect the performance of my model. I don't need zero. So what do? I remove them from my system with null and replace the null with the median of other variables. So I completely remove them. So from the two classes or the class from yesterday, why do you think anybody just want to like give me a wild idea or a wild answer? I don't care. Like, why do you think it should be more important that when we have zeros, we should replace it with the median rather than the mean? Anybody want to take a stab? You might just give the reward. I don't know. But anyone wants to take a stab? Why would we prefer median to the mean? Don't chat GPT. Just think. Why do you think we should prefer median to the mean? Anyone wants to take a stab at it? Come on, put in the chat. Okay. Low variability. Yes. Actually, yes. I would take the answer and I will reframe it as this. The thing with the mean is if there are extreme values at the end, it will influence the result you get. So let's say you have in an age group, you have everybody in that age group is like 20, 25, 26, 20, 25, 26. Then you now go and see somebody that is 65. You know, it will affect the average that you get. So you want to keep things, you want to be able to manage outliers very well, and median is good for that because it's not influenced by the years. Like somebody mentioned, it's not influenced by outliers. So median is a good value to always use for replacing missing values. All right. In some cases, mean works too that's why you always have to like view your histogram. All right. You always want to view the histogram of your data. You always want to view the histogram of your data. For example, you always want to view the histogram of your data. Let's see. SNS dot is about yes. you always want to view your histogram of your data. It tells you if there are outliers or not. Another second way of trying to understand if there are outliers in your data or not is to use the box plots. All right. So if I want to use, I can use box plots to see how my data is distributed in relation to my outcome variable. My outcome variable is what? Outcome, which is diabetes or no diabetes. I want to see how it is related. Are there outliers? Yeah, there is the outlier. So that's why I want to treat those outliers. So EDAs are always good, exploratory analysis are always good to identify if there are outliers in your data, to see the distribution of your data. You can also do scatter plot just to see between two variables, are they highly correlated? If they are highly correlated, it's going to affect the performance of your model. So you want to look at all those differences. And you want to look at, let's take another one more, blood pressure. The exploratory analysis is like a 0 and 1. So it doesn't even make sense to use. Okay, sorry, I used the wrong glucose. So you guys learned about correlation yesterday. So what can you guys tell me about this? Checking. So yeah, those are exploratory. If in case you want to take a look again. So that is exploratory analysis I've done there. I've tried to understand the relationship between variables. Okay. Yeah, not really negative correlated. Negative is this way. Positive is this way. So if you have the correlation, let's see if we can check the correlation. Um, yeah, let's see what I save the time. Let's see what I save time. What is 10 a.m.? Wow. Okay, let's move fast. So yeah, I described the data. I was looking at extremes as well. And keep on going. I feel the missing values. Wait, so I checked, there's no missing values again. I went on development. Essentially, this is my regression logistic. I'm trying to predict probability. And the logistic regression model is a sigmoid function. So this is what it looks like. It's a sigmoid function where there is 1 and 0. All right, it's either if you have a boundary solution here. Yes, let's call this 0.5. 5 is up on 5 below. All right. So you're trying to predict that based on this function, your results, your probability of being in this region or being in the lower end. That's what we are trying to predict. Right. Hope that helps. So that's what it does. Okay, I'll leave the maths for now. So we want to train a model. We've taken out, remember we said the dependent variable is the target, the independent variable is the features. All right, so we've selected our dependent and independent variable. We've split our data into train and test set. Very important. You can't do that. After you split, what do? You scale your data to ensure everything has the same scale. Is measured on the same benchmark or using the same scale to measure. That's what scaling does.
Yeah,
Uh,
time is spent.
Sorry?
Yes.
I can hear you if you're speaking. So I think we've done that. We stopped here. We fitted our model. Anyone recall what we call these guys? Hyperparameters. Always be tuned. There are several methods of tuning the hyperparameters, but yeah, we don't have time to go through them. So what I've done is after fitting the model, I look at what is the most important feature in predicting if someone is going to be diabetic or not. The most important is the glucose level, followed by BMI, followed by the number of pregnancies the person have had, diabetes. Now, what this is called is interpretability. I'm
Okay,
telling,
sorry, Bro Roland, to cut you short.
yep.
Your time is due. Sorry, so you be
What?
rounding up.
Okay, I will round up.
Oh, okay.
I can
So,
enjoy this too much.
okay.
Sorry.
Can I also come in?
Yeah.
So I was trying to see how we can minimize the NLP so we do more of introduction than going into hands-on skills. So instead of doing the hands-on skills for NLP, we can divide up the time and give more time to you.
That's perfect.
So you can split the time and maybe
Hey,
give
that's
me,
Okay.
perfect.
yeah.
Okay. Guys, I'm almost done, I
Yes,
think.
about 30 more minutes. You can give me more minutes.
I need 20. Yeah. I
Okay.
need to be
Take 30, take 30.
guys, I need to be so weird as well. So
Okay.
yeah, we fitted our model. We looked at the importance. Okay, what's more important? What is actually more important? The thing about the collab is you can put in a chat like, okay, suggesting, yeah, weird chats. Please don't use it if you're not sure. Very weird chats that I don't like. So yeah, that's what can produce this AI. So what do we do? We've seen the important features. So what we want to do next is to look at the metrics. Remember, guys, we discussed about accuracy, we discussed about precision, we discussed about recall, F1 score. All this contributes to how good is my model? How good is my model? Now, there are several nuances you want to like, if you have an imbalanced data set, I think I've mentioned it by explaining it. When one group is higher than the other group, if you're trying to predict diabetes, there's a likelihood that those that don't have diabetes, the population that don't have diabetes will be higher than the population that has. So that's an imbalanced data set. So when you're predicting, developing a classification model around that kind of data, your interest is not in the accuracy because that would be deceptive. Your interest is in the precision, that the model is actually predicting the the disease class, the diabetic class. How much is it predicting the diabetic class? Your interest is not in the accuracy, it's deceptive. That's why I said different problems, different metrics. All right. But they are all the same metrics. They're all available for your use. So we looked at the accuracy 69%. Precision is 57, 50, F1 score. So there's a rule of thumb, right? That the F1 score is like the precision and the recall, the harmonic mean of the precision and the recall. Now, there's a rule of thumb that says if your F1 score is in between the precision and the recall, that your model is actually doing good. And I think that is confirmed by the ROC AUC that we see here. Because for the ROC AUC, yeah, it's down below. We'll get to that. So this is a confusion matrix. It's not confused. It's just a matrix. I don't know why they had to give it this name. It's not confused, but it's just a matrix. So this is a true positive class. The class that says non-diabetics are actually non-diabetic. The class that says diabetics are actually diabetic. All right. This is okay, let's call this true negative and let's call this true positive. Diabetic, actually diabetic. Non-diabetic, actually non-diabetic. So the model is able to distinguish between the two groups, which is good. It means we are doing something right. So I want to also view the receivable operating characteristic of. So this there's a cool story around this plot, right? My boss at work was trying to explain, was making a joke around it. People were trying to communicate with each other. I think something has to do with the Air Force or something, and they were looking at how best to define if a communication would be good or not, and they arrived at Rocky UC. So the closer it is to the top right here, the better the model. So our model actually did good by distinguishing and pushing the Rocky UC to 81%. So essentially, our model is good. So what insights am I drawing from it? Good discrimination between accuracy, balance, precision, given by the F1 score. Top diabetes risk factor, glucose, which we all know, glucose, high sugar, that. Age, BMI. Model is better than finding by diabetic person. Yeah, higher precision. So improvement, handling imbalance, class imbalance. I earlier mentioned that there will be class imbalance in the data. So you either handle it. There are approaches to handling imbalanced data. Sorry, we're not going to that. Yeah, that's why I said it's a whole lot to learn. There's no one class will not solve it. All right. Yeah, deep learning. Essentially, we just picture, whenever you think of deep learning, picture that image of input layer, hidden layer, and the output layer. There's a math behind how the layers connect each other. There's a weight applied to the node that connects each of the layers. Do we have time to explain each and every one of them? No. But look at that image and always recall, okay, if there's a connection, there will be something that is connecting everything together. All right. So yeah, the popular library for TensorFlow for deep learning is TensorFlow, Keras TensorFlow. So there are two types, sequential model. We are building sequential model in this case, and using dense layer. The dense function we are using here is to develop hidden layers. So I did build a very simple, I think it was two hidden layer, right? So this is the input layer. Okay, one layer. And this is the hidden layer. And this is the. So if I were to write this down, if I were to sketch this, it will be the inputs, which are 16 pictures. The hidden layer, which is 8, 1, 2, 3, 4, 5, 6, 7, 8. Then the output, which is 1. So it's either diabetic or not diabetic. So it just has to be 1, 0 or 1. So what is the next step is I compile everything together using, what am I trying to predict? Loss function for binary classification. Thing is, there are so many there are so many things you want to like break down for everyone. Like there are so many things you want to break down for everyone to understand. And yeah, you can't really do that much. I want to break down everything. What's the loss function? What's the optimizer? Hopefully I gave you a good recommendation with this book because it did cover it. So yep, that's a simple solution. But yeah, let me open this up, run it, ask me question. Later on, you can text me on LinkedIn or I think Telegram. I don't know how often I go there, but you can drop a message. I will get back to you. You can text me on, chat me up on LinkedIn, send me an email. Try to. Okay, hands-on machine learning with scikit-learn and TensorFlow. It's popular. So simply remember what we mentioned was always look at the validation loss and the training loss. The training loss started at, let's see, what was the training loss when it started? It was 0.5914, 0.5789. That was good. So it's, if both should be decreasing. So if the training loss is decreasing, the validation loss should be decreasing. If the training loss is decreasing and the validation loss is increasing, your model is likely going to overfit at the end of the day. If your training loss is, anyhow, if one is decreasing, one is increasing, is overfitting. If one is decreasing and one is increasing, either way, it's not fitting properly. It's the accuracy that will tell you finally what's happening. So let's look at the accuracy. So always, the truth is the validation accuracy will be a bit lower than the training accuracy, but not extreme. All right. So at the end of the day, the validation accuracy is 0.8. The training accuracy is 0.7. The training loss was 0.4. The validation loss is 0.49. For me, this is good. It's not extremely different. Just be 0.1 something different, which is what you always want your model to have. So what do? We evaluate the performance of our model. The loss is 0.4, very minimal loss here, and the accuracy is 0.79, which is good. Good for our model. I wouldn't say I have the time to explain each and every one of them. So if you look at the training loss and the validation loss, raw curve is good. So the deep learning model even went a step further. In our classical ML model, we had 8 here and few values here. 33, I think 21, but it went a step further and say, no, it's 84. So we'll look at, okay, F1 score, accuracy. So it's in between, it's still good. And our rock AUC curve, still good. Training and validation loss, yeah, training loss is higher than validation loss, which is okay. So look at the training accuracy. Now this is the problem, right? It's not, we don't expect it to go over and we don't expect it to be too low, but it's within the thing is this, we're also observing something that if we train a bit further, they might completely go apart. That is the essence of some things we discussed earlier. Early stopping, regularization, dropouts. These are their importance. If I didn't insert dropout or early stopping, it's going to just train. Then at the end of the day, you see it to just completely separate from each other. That will result in overfitting. Right. So those metrics or those techniques were installed where there's a place I imputed them that I didn't mention. I think I skipped it. Yeah, I did include early stopping. Include early stopping to ensure it doesn't just continue to the end. Stop at some point when you've hit certain validation loss. If your validation loss is getting too high, stop. If it's getting higher than the training loss, stop. So that's what early stopping does. And that was why I was able to minimize my error. You see what it's happened here. Immediately saw that it was getting too wide, it stopped training. So those are techniques. Guys, thank you for coming. I think I've enjoyed this so much. I like doing this every year. And like it's not like a kind of a goal for every year to always do this. So thank you for listening to me, and yeah, best of luck on your learning journey. I appreciate you guys for spending your weekend with me, and yeah, thank you so much. In case you have any question, yeah, I'm done for today. I'm done for today. If you have any question, yeah, we'll try to. Yeah, my LinkedIn, I'll just drop you on the group. I'll drop you on the chat. Anyone can, you if you want to reach out, yep, yep, feel free to do that. Yeah, I'll go and look for my LinkedIn. I'm sorry. Anyone has any question? Hope you can. I think you can take it up.
Thank you so much, bro Roland. It's been an exciting time with you here.
That's my LinkedIn.
We are so glad to have you around and to give us this insightful, should I say, lectures now. It's more than a lecture. This was more like a hands-on and experiential thing. Thank you so much for making time to be with us. We
Thank you,
really
guys.
appreciate it. Yes.
Yep, yep, yep. All right. Well, my day just started, so I would see you guys. Maybe I might pop in or pop out. I don't know. But yeah, have fun and happy learning.
All right, without taking much of our time, I would like us to go into our next program. We are supposed to go into the introduction to natural language processing and then the large language models, generative AI. I don't want to take our time as I welcome our brother Joseph to continue with us with his team. You're welcome, brother Joseph.
All right. Thank you so very much. Thank you all for staying to this point. I would like to thank Roland for taking us in that section. He has done a lot of work. And while he was teaching, I was seeing that, oh, should we still do some sort of like hands-on session for this introduction to large language models, natural language processing, Gen AI, and foundation models. So, and I was feeling in my spirit that we should leave that part out and spend more time discussing the basics of natural language processing, generative AI, large language models, and foundation models. So I will be downsizing what we're going to be doing at this point. So I expect that it is going to be interactive. So we're going to spend a lot of time on just a single slide, and we just digest every single slide and have some sort of like a foundational knowledge on where the feed is going and where the knowledge we've acquired from this supervised learning and deep learning is going to take us to this generative task. So I will try to share my screen, and feel free to ask questions in the comment box. Stay muted as we've always done. We've always stayed muted. So I expect that we just keep to that while we interact more in the comment box. So I will try to share my screen again, and then I'll get us started. All right. Okay. Oh, yes. So Roland actually handled last year's, introduction. Last year, we actually did more of introductory part of machine learning. So we did machine learning with Python, and he actually handled that course. And just like he said earlier, if you need to go to watch it, go to our YouTube channel, go to our GitHub, download all the slides, download his notebooks, download all the links that you need to get started in this course. So this year is just, we kind of like have an advanced level summer school compared to the one we had last year. So if you go back and watch all that we did last year in our first summer school, it's going to really help you to get your hands started on where this field is going. So I'll highly recommend that for you. And all the recordings that we have here, we're going to push it to GitHub. We're going to push it to our GitHub. We're also going to upload all the recordings on our YouTube channel. So check our YouTube channels and see how you can use all these resources. So I will be handling introduction to NLP, that's natural language processing, large language models, generative AI, and foundation models. Just like I said earlier, if you want to become a data scientist or an AI engineer, there is a roadmap to that. There is a ladder that you have to climb. You didn't just secure admission for a master's or a PhD. You started somewhere. You started in KG, you went to you went to primary school level, and then you went to secondary school, you went to the university, to your undergraduate, then you went for master's, then PhD, and then if you want to become a professor in the US in particular, you do a postdoc, and then you become a professor. And even for you to retain your professorship, even to get a professor, you have to keep writing papers and securing grants and training students and doing all that. So you can see it's a roadmap. For you to become a professor, there is a roadmap to doing that. If you want to become an industry expert, there is a roadmap to becoming an industry expert. So it is with data science and AI. I know there's a lot of enthusiasm from you. I want to become a data scientist today. You know, when you see Roland speaking and you want to become like Roland in a day, it's not going to be possible. It's going to take years of experience. And I told you, and I always shared with you, that I came from a biochemistry background. And I didn't just start doing natural language processing immediately. Immediately I left biochemistry or I started bioinformatics and all that. No, it took years. It took years of experience. It took years of learning. It took years of reading blogs, watching hundreds of YouTube channels, and taking a lot of courses in machine learning, in math of machine learning, in AI for drug discovery, and a lot of courses that I've taken. AI for machine learning for biology, and a lot of courses I've taken. So when we speak, we are speaking out of experience, because at least I have close to 6 years experience in machine learning and AI. Roland has even more years of experience than I do. So Roland has at least more than 10 years experience. I don't have up to 10 years experience. At least I have about 6 years experience. So how many years of experience do you have? You may have just a day experience, or maybe just 2 days experience. Maybe you just started yesterday and it's just today. So what I want to tell you is that you have to have patience, you have to have grace on yourself. You don't have to condemn yourself that, oh, see, Roland is very proficient. Oh, I'm not understanding what is regression, what is RNN, what is all this. You can't know it in just 1 week. It is going to take time. And you have to be in the midst of people who are doing these kind of things. You have to attend conferences. You have to make presentations. You have to be with your peers. just as you are in this summer school. That is the only way you can learn. That is the only way you can grow and become like some of us who are also growing, because I'm not like Roland. Roland is far ahead of me. So I'm still aspiring to become like him. And I'm still aspiring to become like some of you who are here, who we know you are experts in this field. I can't even be your own teacher in this NLP and all this that I'll be teaching. So I would like you to take out some time and have some grace. Have some grace on yourself, and welcome have some sort of patience. Be patient with yourself, but be resilient and be consistent. So it has to do with resilience, and it has to do with consistency. When you have these two things I mentioned, resilience and consistency, you also become like Roland, and also an aspiring Roland like me. You also become someone like me, who I'm just aspiring to become like Roland. So those are the two key things I will give you. Don't give up, be consistent, and be resilient. Those are the two key things that will keep you going, and you also become an expert in data science and AI. So I was introduced before. I am doing my PhD here in biomedical engineering, but I specialize in modeling and biomedical data science. So my AI niche is basically on AI for drug discovery. And how did I get to AI for drug discovery? I graduated with a biochemistry background, and I never had any background in statistics. Deep background in statistics, in math, in computer science, even though I've always loved maths and I've always done well in math. And I have math background. I always love math and I can do math and computer science and statistics. But I was never brought up as a computer scientist, as a statistician, or as a mathematician. I was brought up as a biochemist. So I only learned all these things after graduating. So my journey only started in 2019. So you can see some of you have been in the field before me. I only started in 2019. I've always loved computing, and I've always looked out for opportunities to learn computer science and to participate, to take have some training programs in computer science, and also in AI and in machine learning and all these fields. So I started in 2019 taking machine learning class. My first machine learning class was in 2019. And then the journey started from there. And those of you who stayed back, if you didn't stay back yesterday, I will encourage you to go back and watch the recordings of yesterday. I spoke a lot about my background and how you can also get to learning these things. And you can also, in the next couple of years or months, 3 to 6 months, you are going to be better in coding. You are going to be better in Python, in machine learning, and in all these fields. So without wasting time, I will keep moving on, and I will tell you how I started. And also, just to also highlight that when I moved into machine learning, I didn't just start doing AI for drug discovery. I started with machine learning with all the things that Roland is teaching you. If you can Google my project, you can just Google my name. You find a project I did in 2022 on churn prediction. You can find my projects on support vector machines, on random forest, and all these predictive models. You find my models online. You find out I did deep learning. I did some of the key algorithms in deep learning, like RNN, recurrent neural network, or CNN. You find long short-term memory, all the ResNets and all this. I did these models by 2021, 2022. So it was a journey. I didn't just jump into AI for drug discovery. I didn't just jump into NLP. It will surprise you to know that I only started doing NLP last year. Not last year, I think that was for 2023. So I only started doing NLP by fall 2023. So for some of you, you are more experienced in NLP than I am. But it's because I'm resilient and I'm passionate about what I do and I want to solve problems. So I started there and I take on more difficult tasks and then I keep the journey going. So you can also do that. You can start from there, keep building things, do a lot of projects, participate. I work with the UK Biobank on different data sets. Also here in the US, you find some papers. Roland was talking about Sharply values. I worked on Sharp, that's explainable AI. You check one of my papers on explainable AI with the NIH Overs database here in the US. So we've done all these things. We've done multimodal models. We've done all these things. We've done time series modeling. We've done explainable AI, interpretable AI, and all these models before coming to something like AI for drug discovery. So when you do all this that Roland is teaching, you can also come to this level. So I want to just introduce you, and then all that Roland taught you, we're going to push all the notebooks to our GitHub repository, and you can be able to practice them at your own pace. So I'm going to go on to the next slide. So I would like to still ask, what is artificial intelligence? We've been discussing this over this time, and I would like to get your feedback in the comment box. What do you think when you hear about AI? What comes on your mind? Just type in the comment box what you think about AI. So it's going to be very interactive, just like I said earlier, because we're going to spend all the time on these slides and we are going to be learning together. All right, someone say, a machine thinking like human. Automation, oh, I love that. A machine that thinks like humans. That is cognitive functions. A machine that has some sort of cognitive functions to be able to perceive just like the human mind, that can be able to reason, that can be able to learn, interact with the environment, and also solve problems. Thank you for the definitions. AI is self-reliable machine, a human-like responding machine. That's nice. Artificial intelligence. Okay, artificial intelligence is the ability of the machine to be able to perform tasks that humans can perform. Oh, nice. So a machine can perform the task you can perform. That is why it's artificial. It's not human, but it can do tasks that humans can do. Artificial and intelligence. Artificial, it means it's non-living. But intelligence means is doing something that human beings can do. Human created a replica of human beings. Okay, I think I lost that. A machine that mimics human intelligence but performs faster than human mind. A machine that performs tasks faster than human mind. We are getting to an era, and that era is called AGI, Artificial General Intelligence. People are building an AI that will be more intelligent than humans, that can be able to work even without data. That is the era we are going. AGI, you will find Google and all the IBM and all the top tech companies. They are building AGI, Artificial General Intelligence, that can be able to think more than humans. And I love that definition that someone says that a machine that can think or can perform tasks more than humans. And that is why Roland was talking about the ethics, because when we have an AI that can do things more than humans, then we should be able to monitor and control the AI. Otherwise, AI will control us. And that is why we have some sort of like delay on releasing AGI, because if we release AGI, then it means AI is going to have more power than us, and we can't control AI. So we have to have control over AGI before it can be able to control us and harm us. Because AI, as long as it's beneficial, it also has a lot of risk and danger. And when it gets into wrong hands, it can get people killed. It can get a lot of things. It can create new diseases. It can do a lot of things. New uncurable diseases. In fact, thousands of uncurable diseases may come out. And what is that going to do? It's going to kill, it's going to wipe out humanity. And so we have to, and that's why you have to also come in. And that's why we're selling this to you. You also have to learn. We all have a responsibility to be able to control AI, to be able to have control over this AGI. So without wasting time, I will just go over what we have now. Thank you for your responses. You are all excellent. And I hope you're all learning in the comment box. They are very excellent responses on what artificial intelligence means. And I think with the AGI, or with the AGI just slotting, you've gotten to know that all hands are on deck to ensure that we control AI. We're able to control AI, and AI doesn't have control over us, but we can be able to direct how AI can only profit humans, but not to be at the detriment of humans. And not only in healthcare, but also in different aspects, like in the military, in developing weapons and all that, because when it gets into the hands of the wrong people, then they are going to wipe us all out of this, the face of this world. Or they can wipe out ethnicities and different things, people they don't like. People, a lot of things can happen. And that is why we're encouraging you to learn this, so you can also bring AI, begin to think about your own discipline. Begin to think about climate change. If an AI is so powerful that it can cause rain, I hope you know that we have artificial rain, especially in China and in some Asian countries. I think is it in UAE or in Dubai, we have artificial rain. So if we have such kind of artificial intelligence that may decide to say, okay, let it rain all over the world for a whole year, then what is going to happen to the world? Think about your own field. How can AI disrupt a lot of things in your own field? Think about the positive sides. And that is why we have to come in to only bring AI that profits humanity. And here I gave examples on how we interact with AI every day. And Roland has already done that. I won't be going much into that. But we interact with Siri voice assistants, with Google Assistant, with customer service chatbots, generative AI such as ChatGPT, gaming, predictive models for risk prediction and protective factor in healthcare. Roland spoke about these risk factors in cases like type 2 diabetes, or protective factors. With AI, you can be able to know the risk factors and the protective factors, and that will help you to live a more healthy life. And also in forecasting models in businesses, we spoke about churn prediction, to know whether you can retain a customer or that customer will not be a repeat customer. Mobile banking, fraud detection, customer management, social media such as Facebook, and all these applications of AI. So you can see AI is all around you. You interact with AI on a daily basis. You use Google and you use, if you are using a phone, if you have a cell phone, it means you are using AI. Driverless cars, Roland spoke about Tesla and some other driverless cars out there where we're using human data to train this AI. But we're going to an era where we may not really need data. We may not really need data to train AI, and that is AGI. But as far as we don't have AGI, we still need quality data. Otherwise, the wrong data that we feed into AI is going to bring wrong results. It's going to bring negative results, and it's going to cause, like maybe driverless cars going to cause accidents because of maybe drivers that are reckless. If you have such kind of data, then you are going to feed in to training these models. And it means all the driverless cars can also make mistakes. And that is why you have to, because we are all Christians and we are all encouraging you and we preach to you to live a life of integrity and to obey laws. If you are in the US, you obey the laws of the US and you live to the best of your ability. And by doing so, you are giving out positive data, good data, high quality data that can be fed into this AI. As you interact with ChatGPT and other AI models, as you interact with social media and all these AI models, your data is being collected. You are indirectly sending data to these sources. And those data sets are being used in training these models. So just to let you know that if you're using ChatGPT and you don't turn off that feature where it says your data is being collected and is being fed into the model, into the public model, it means all your interaction with ChatGPT, it has been collected and your data has been trained on ChatGPT. Well, I didn't see that feature and my data was being collected until I saw that feature and I went and turned it off. But even at that, you can see a lot of data from the internet is being collected and trained on AI models. And you can see companies are suing, maybe they're suing ChatGPT, oh, you collected my data, you scrapped my website and all that, and they're suing all these AI companies for data, for breach of privacy and all that. And even in the healthcare, you have some companies that lost their data, like 23andMe. It was a very good healthcare data, but they actually lost a lot of their data sets, and that actually resulted to their bankruptcy where they had to sell their company. You know, so it's high time we come to that level where you are conscious of what you're communicating out there, because it's going to be used, and also when it comes to even crime detection, you may be wrongly detained or even sent to prison because of how you interact and the way you're interacting with all these things. So your responses today may stand against you in the next couple of years. It may not be up to 3 years or even 5 years. So it calls for you to give your life to Christ. That's where I'm getting to. And by doing you will be able to live a life of integrity, and you have the fruit of the Spirit, and that will guide you in your living. So without wasting time, I will go to the next slide. And Roland has already done this, so I'm not going to go over all this again. We've talked about machine learning, which is a machine, and it learns from something, and it learns from an input data. Roland has done justice to this, and this started in the 1970s, where again a lot of applications like medical imaging, where AI was able to recognize images. So, and also for weather forecasting, this gained attention in the 1970s, and this was based on data. And Roland has already done that. I won't be going much into that, but you can use ML to train data and detect patterns where you make predictions and help in decision making and policy making. The government make policies, and non-profits or even industries, universities, they make decisions based on these trained models. So that is trained based on the input data. Deep learning, on the other hand, and Roland has already done this, he mentioned to you that this is a supervised learning task, like classical machine learning is supervised, where you have a labeled data and you have a target. You have a target output you are expecting is either true or false, is either positive or negative, is either this person has a disease or doesn't have a disease, is either true or false. So you have is either 1 or 0. So you have those targets, and that is what is called classical machine learning, or you can also call it supervised learning. It's being supervised. You have something, there's an expectation from your data. Your data is either giving, maybe a patient is having a high risk for maybe prostate cancer, or is not having a risk for prostate cancer. So there's an expectation from your model. And from here, he already taught you how you can split your data into train. You train your model on a data set. It could be 70%, 70 or 80% could be your train set. And your validation is a subset of your data. It's a subset of your input data. And your validation could be into different segments. It could be into different segments, and you can split it into different segments, and you can be able to do the validation. And also the test set is also a small set that you train your model. If you have any questions, just drop in your comment box for this slide, and we'll be talking about it. So your test set is different from your validation set. It is different from your train set. One big mistake people make is they allow data leakage, where some of their trained set gets into their validation set and their test set, and their model gives a wrong prediction. So one of the things you want to do is you train your model on a data set that the validation and the test set have not seen. Okay, I mean the other way around. You test your model on a validation and test set on a subset of your input that the train did not see. And that's what is called classical machine learning. And when going down to deep learning, he already said deep learning is trained on unlabeled data. You don't have an expectation. You want to gain new insights from your data. So your data is able to, your model is able to learn new patterns, is able to learn new things, get new information, and is able to process even a large amount of data. So for classical machine learning or supervised learning, you may not need a massive data, even though a good data is needed for training machine learning. But why it can tolerate a small data set, that's for supervised learning or classical machine learning. Deep learning does not tolerate a small input data. You have to have large amounts of data because it's going to learn from one layer to another. And that is why it's called unlabeled. So you are bringing in a lot of data set that you are learning new patterns, and Roland has already done that. And we already have some examples on how you can, some applications of deep learning and how you can be able to do that. But I just wanted to reiterate that it requires massive amounts of data than the classical machine learning requires. And in some cases, if you don't have massive data for deep learning, you can actually pre-train your model. You can train it on an existing model. You don't have to train your model from scratch. And we're going to deal with all that subsequently. So your deep learning requires less human intervention, unlike your classical machine learning or supervised learning. Your deep learning requires less human intervention and can produce more accurate results. That is unsupervised learning than traditional or classical machine learning methods. That is supervised learning. new patterns are learned. Roland has already touched on all this, so I won't be going much into that, but I just wanted to let you know that these things exist in deep learning. And that is why it's different. And we have examples, we have some architectures. You can see that we have different architectures or methods, classical machine learning methods like support vector machines, random forest, XGBoost, linear regression, logistic regression, and different other ones that we have. All these decision trees, you think about different other models that we have for supervised learning. But when it comes to deep learning, we have different architectures. I think Roland spoke about K-means clustering. He spoke about PCA, that's principal component analysis. He spoke about different other methods, deep learning, other deep learning architectures like CNN. And what is CNN? Can I get in the comment box? Does anybody know what CNN means? CNN. I hope it's not. The first time I heard about CNN, I thought, oh, it's a news outlet out there. That was the first time I heard about CNN. But I say, oh, it's not. Is it not? Is it not the news? Oh, okay. Someone just gave us. Someone said it's central neural network. Is it central neural network? Oh, okay. Someone gave us convolutional neural network. Convoluted neural network. Convoluted neural network. Is it convoluted neural network? Let's have more answers. There is something I'm looking for. CNN. What does CNN mean? The full CNN. Convolutional neural network. That's right. Convolutional neural network. So this is a deep learning method. What about RNN? Who knows the full meaning of RNN? RNN. Recurrent neural network. That's good. What about MLP? MLP. 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 Let's be fast. I know we have experts here. Let's learn from you. Multilayer perception, okay? Multilayer perception. These are deep learning methods. So let's be all learning together. And what about ANN? ANN. ANN. I'll type it in the comment box. ANN. It's foundational. It's foundational to neural network. Okay, artificial neural network. Nice. And what about what about this? LSTM. Okay, how I know the data is leaking is you can check the points. Like I trained a model last week and I realized that some of my test set was, you can check the columns. You can actually check the columns. I mean the rows. Check the rows of your data. Are the rows in your train set the same as that of the test set? If that happens, then you know something is wrong. You have the same. You don't have different test set when compared to train set. Long short-term memory. Okay, so someone gave an answer to long short-term memory. So that's another method. Long short-term memory. Long short-term memory. I love that. What about this? what about VAE? VAE. Who knows what that means? What are we learning? We are learning some deep learning methods. We just want to get used to them. Then when we move on, we can now dive more into what they mean. Okay, without wasting time, VAE means variational autoencoders, and we have different other architectures we'll be looking into. So from here, I will move to the next slide. If you don't have any question, if you have, drop in the comment box. If you don't have any question, if you follow, put plus. If you don't follow, put a minus in the comment box. All right, that's good. So let's move on to the next slide. So now we have types of machine learning, and we've already dealt with this, so I'll just highlight it and move on. Roland has already dealt with it, and I dealt with it on the other slide. We have supervised learning, and he spoke about task-driven. It's task-driven. You want to predict whether a patient has cancer or doesn't have cancer. It's task-driven. And that can be either prostate cancer, a patient has prostate cancer or doesn't have prostate cancer. And he spoke about regression earlier and classification tasks. I don't have to go into that. Data-driven, unsupervised learning, data-driven, and spoke about clustering. We have clustering as a method, as an unsupervised method. So this is an unsupervised method where you can cluster, where data sets, where it clusters your data, where data sets that shares, data points that shares similarities or shares things in common. They form clusters. And those that don't share things in common, they are apart. So you can be able to cluster your data into different clusters. And reinforcement learning, I mentioned earlier, well, I think that was yesterday, I mentioned briefly that we also have reinforcement learning. It's an algorithm that learns to react to an environment. And what it does is it gets feedback. And it's based on the feedback that is either rewards. It either rewards positive or it rewards negative. You either have a positive reward or a negative reward. And right here, what we are doing with your attendance and with your participation, and we're taking note of all this participation in the comment box and with asking questions, with tapping you are following, with all this. What reward are we going to give you? Can you type in the comment box? Your attendance, your participation points, your attentiveness. What reward are we going to give you? Knowledge and certificates. The reward is knowledge and certificates. Okay, so knowledge and certificate, and that is an exact thing that happens in reinforcement learning. It learns to react to an environment, and it rewards it based on that interaction. I won't be going much into that. It's a topic of its own, and we will spend more time doing it. Or you can learn also in our last summer school, and also go over our annual conferences. We had our first annual conference in 2023. We had another one last year, and we're going to have another one this year. Go over our annual conferences. We also treated this topic, and I will encourage you. I don't know, but you check our platforms and register for our annual conference. Our annual conference is going to come up in August, and when you register, you participate around August 8th to 9th, thereabout. I've forgotten the exact date, but it's within that time. And when you register to attend, you are going to still learn data science. We are going to have panel discussions, people who are going to be in the social sciences, arts and humanities, management sciences, those in STEM, they are going to be in their own session. They are going to have their own breakout rooms. And we're going to be discussing hot topics in these areas. And we're going to be learning from one another. So I encourage you to come, and you're going to learn a lot in that annual conference. So we're going to treat that, and we've already treated this reinforcement learning in our past annual conferences. So as you look up our videos, our past videos, don't only look up videos or recordings from our summer school, but also look up all recordings on our YouTube channel. Follow us on our YouTube channel, and everything is free. We're not taking any money from you, and there is no hidden fee. Even on our website, everything is free of charge. We're not taking any money from you. So anytime you subscribe, know you're subscribing at your own, it's for your own personal use. And we're not taking any money. Our website is not monetary or based, or any of the services we render. None of the services we render is monetary based. So you can learn all this. You can be able to pick all these things from our YouTube channel and learn from our past events, past conferences, summer school, and even symposiums and all that. If there is no question on this slide, just type a plus in the comment box and we'll move on. If you have a question on this slide, I think Roland did a great job on this slide, so we don't need to go on this, and I think I also treated it on the last slide. All right, thank you so very much. And we're doing it for the sake of God, and this is a Christian nonprofit. So it's a ministry we are doing, and our joy will be that you will be able to carry this, and you will be able to propagate the word of God. When you are able to teach people with machine learning, you are leading people to God, and you are affecting their lives positively. So I would be talking about AI revolution, and Roland has already handled all this, and I've also touched on decision trees, lasso regression, logistic regression, naive support vector machines, and all the other classical machine learning method or supervised machine learning that we have. And also I just spoke about deep learning. I spoke about ANN, CNN. I asked you just a while ago. These are the popular ones we knew as from 1950s, 1970s, and down to 2012. Deep learning became very popular. And by 2017, we have attention mechanism where transformers became very popular. And then ChatGPT came, and things are becoming better and better. Large language models, agentic AI, a lot of things are coming up. So with this, we moved down from 1970s, where we had speech recognition with AI and a lot of things happening. Deep learning has added a new layer for all that we do in AI. So the field, the discipline kind of keeps revolving on and on. Things keep changing, just like Roland said earlier, and you have to keep connected with the news, with everything. And if we have time in the comment box, we'll share some news sources, and we do share it on our platforms. And you can stay connected with Andrew Unk and a lot of other top people in AI. You can go on Medium, have a page, have an account on Medium, and try to connect with this community and see how you can get all the news in AI, and you can also develop and be able to expand on your skills and know where the field is going. So we can see in the last couple of years, we've had a lot of new developments, things changing, where natural language processing became so popular in 2017 with the coming out of a paper called Attention is Everything. Attention is everything you need. Attention is everything. So, and with that, transformers came to be, and then we had large language models. We now have agentic AI, we have generative AI, we have explainable AI. Things are getting better and better and better. And these things we keep changing on a daily basis. As we are talking here, things are changing. And that is why you have to stay connected with our community, because tech is our goal. It's one of our aims and objectives. So you always find information on our groups. You always find things going. We always share information on our LinkedIn. Everything that is going, we keep you updated, and you stay connected with everything that is happening in AI. And let me just pause here and ask any question on this. Don't bother to know what generative AI means at this point. Roland touched on explainable AI. I also touched on explainable AI. Large language models, natural language processing, don't worry about this. We're going to treat this in the next couple of minutes. If you follow type plus, if you don't follow type minus, if you have any question, drop it in the comment box for this slide, and we take on from there. We take off from there. All right, it seems you all follow. So we are going to move to the next slide, and here I'm going to be talking about natural language processing. So what is natural language processing? I will briefly talk about it. Natural language processing, just like the name implies, natural language. What is natural language? Natural language. So I'm speaking a language as I'm taking this course. Natural language is natural. It's a language that exists. And what am I doing? I'm speaking it. Natural language. You know? And so when we talk about natural language processing, what do we mean? It means we're talking about the language that we're speaking. It's a natural language. It's English. I'm speaking English. And you all have languages. We have Spanish. We have Russian. We have different languages. We have French. We have different languages in different parts of the world. You have a language. So these are languages. These are natural languages. But when it comes to a machine, to a computer, how does it understand or process this language, this multi-language that we have? So natural language processing, that's where the processing comes in. The machine, we have to process our natural language, the language we speak. The machine the machine processes it into a way that it understands it. So what the machine does is it processes it. What it does is the AI, that is artificial intelligence, enables computers to understand, interpret, and generate human language. You can see a strong application of artificial intelligence. It has a strong application in what? Natural language processing. Because computers are unable to process human language on their own. So artificial intelligence has to come in. Because it's intelligent, it can process the natural language that we're speaking so that computers can understand and do things faster for us. So it can interpret our language, it understands our language, and that's why when you type something into your computer or your phone, it understands and is able to interpret, is able to generate something for you. So it automates text understanding at scale. So you have a lot of things you put into the computer, and is able to generate a large scale of words for you, or do it, kind of does a lot of work for you. So it does it at a large scale than humans. It does things faster than what humans can comprehend or what humans can do at a time. It processes in seconds or in even milliseconds than what humans can do. So I'll be talking about the core intersection of this natural language processing. So when you hear about natural language processing, think about linguistics. People who studied linguistics, they are here. They are here in this summer school because it connects with them. Natural language processing started with their field. So it connects linguistics, that is the study of languages. It connects computer science and AI. And that is why we have what we call computational linguistics. Computational linguistics. We have computational journalism. computational biology, computational chemistry, computational whichever field. And that's why you're also representing your field here. And you can also type in the comment box, how do you coin that in your own field? Computational what in your field? As a participation point, how will you call it? Is it computational biology? Is it computational geology? Is it computational what? Type it in the comment box and let's see. Computational biology, okay. Computational economics. Computational economics. I was doing a project where we're trying to predict, we're able to get data and predict businesses that may not survive in the next pandemic. And you see people trying to even predict when the next pandemic is going to come up, you know? And people are trying to predict when we have a natural disaster, which businesses are going to be affected, which countries are going to be affected most. And that is where it has a lot of applications in economics. And people are mentioning computational chemistry, computational food scientists, computational English, computational chemistry, computational engineering, computational animal nutrition, computational statistics. Oh, I love all I'm reading. And you are coining it for your own discipline. And who knows whether this will become very popular, even if it's not popular. But you can see that it has a connection of natural language, linguistics, computer science, and AI. So there is a bridge of communication between humans and machines. What it does is it bridges communication between humans and machines. The human language, you feed it into a machine, the AI comes in and is able to interpret it on large scale for you. And it has a lot of applications in chatbots, in machine translation, in sentiment analysis, in information retrieval. If you don't understand what machine translation means, sentiment analysis, I'm going to talk about that. Don't worry about that. In the next slides, I'll be talking about that. And it also empowers technologies like Google Search, Siri, and Alexa. You've used all these on your phones, Grammarly, and also ChatGPT. You use ChatGPT to generate information for you, to do a lot of things, and to correct grammar, and a lot of things. And even in biology, like in computational biology, you know, we have a sequence of DNA. If you purposely leave a mutation on a particular sequence, a non-sequence, ChatGPT is going to correct it for you. If I know a protein, a particular protein has a number of sequences, maybe it has 76 amino acids. If I miss any amino acid, it's going to correct it for me. And that's why when you type something in ChatGPT and you have a lot of typos, typographical errors, ChatGPT corrects it for you and still gives you the right answer. So it has a lot of applications in these disciplines. If you follow on this slide, type a plus. If you don't follow, type a minus in the comment box, and let's move on. Computational neuroscience, I love that. Okay, you all follow. So let's move on. So here I'm going to be talking briefly on the history of natural language processing. We have natural language processing. I told you it started. It didn't just start with natural language processing. Just in 2025, there is like a roadmap where we had all this translation, which started in the 1950s. People have been doing ELISA, or some people call it ELISA, whichever way you call it. People have been doing this. And there was a first AI winter conference back in the 1950s, early 1960s. And then we went into the 1970s, I spoke about, where we had the first neural networks, semantic networks, which came in the 1970s. And then we had a lot of things happening in the 1980s. But all that was, people, there was like an enthusiasm. People will come and it will go. People didn't really find a lot of applications. But in the early in the early around 2012, basically around 2012, we had a lot of applications of CNN. That's a convolutional neural network, and a lot of other deep learning methods. We had a lot of applications, and that was why there was a massive boom. And by 2017, we had natural language, we had transformers, and also attention mechanism, and made things better. And now we had NLP and large language models, agentic AI, and a lot of things are happening down the line. So there was a journey. You can see we didn't have this just today. It's just in the 1990s that we had RNNs and long short-term memories. And then we had the web embeddings and language modeling. Google Translate came in 2000s. So it's a journey. And that's why we're telling you that this is a journey. In 2010s, including 2012, I mentioned 2012, I mentioned 2017, 2010s, that's between 2010 to 2020, we had word-vec, word-to-vec, we had encoder, decoder, we had attention mechanism, we had transformers, pre-training models, and transfer learning. All this came in 2010s. That's between 2010 to 2020. And then from here down, we're having large language models, agentic AI, and all the other models that are coming. So when we tell you, your journey is going to start from here, maybe you just started your journey with just okay. So okay, so just like I said earlier, thank you for calling my attention to the time. So just like I said earlier, we're going to do more in-depth. I took it, Roland did a lot of work on that, so I wouldn't be going to the hands-on for this section. We are already doing hands-on in the comment box. You are all learning. I just want you to take some more time on this so you all understand the concepts, because this is where it starts. And if you're able to understand this very well, then you can be able to we can send the notebooks to you. You can practice on your own. You can ask questions. You can also volunteer we have volunteer roles in our research department. We have a research and technology department institute. We have NELIREF Research and Technology Institute. And you can also volunteer and join our research team and learn more from our team. You can go on our group and search for call for that, and you can be able to join our team, and then you will learn more. So I will continue from here to the end, and then we'll stop wherever the time, whenever we get to the time, we'll stop and take attendance, and then we'll call it a close for this year's summer school. But just to take it on, just wanted to also highlight that you can see from 1950s to 1980s, we had rule-based systems. And that is ELISA. From 1990s, please admins, if you can help check the comment box and mute people, that would be very helpful. All right, and then so in 1990s to 2000s, what we had was statistical methods, and that was HMMs. Who can tell us what HMMs mean? HMMs. 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 Hidden Markov model. Hidden Markov models. N-grams. So these were statistical methods, and they came between 1990s to 2000s. And I worked, I had one of my professors from Georgia Tech. He built a model in the 1990s, within this time, and he built GMAC model. And that model is used in predicting the location of a gene on the chromosome. And that was in the 1980s. And he built that model in bioinformatics, and he leveraged these HMMs. And there were the people that actually started this, built a lot of things in statistical methods. And then in 2010s to 2020s, After that's from 2010s to 2020s, we had deep learning and world embeddings. You can see everything here. We had all this, and we're going to send you all the slides so you can learn more in detail. But in 2010s to 2020s, we had world embeddings. We had world embeddings and also deep learning. And then today we have large language models. We have BART, GPT, and all this. I'm going to be asking you on the other slides to know what BART or GPT mean. If you understand at least the history and the concepts, can you type in the comment box? Type a plus if you don't understand the history. This is just an overview. So just to tell you that there is a roadmap to even what we are doing. So you have to also be patient with yourself. You will get to know all this, but just like deep learning and all this, the AI has a history. There's like a history. There's a timeline in how things are getting. Like even large language models, now we have agentic AI, and we all are going to have agents. We are all going to have agents while training our models. In drug discovery, I'm also bringing agentic AI into my drug discovery pipelines. So we're going to have all agents everywhere, monitoring and doing a lot of things, performing some functions and doing a lot of things and all that. So it seems we all follow. So I'll move to this slide. And here I briefly explain what text pre-processing in NLP means, because you have to pre-process the text. You have to pre-process the text because we're talking about natural language. So we have different steps to do that. We have lowercasing. We have lowercasing, and the purpose of lowercasing is to normalize text by removing case sensitive. For instance, you have the dog. The dog. The dog. So what are you removing here? Case. Who can observe what happened between this and this? What is missing? Type in the comment box. What is missing? What is missing? What makes them different? The dog. The dog. What makes the two of them look different? Type in it. Initial caps was removed. Lowercase and quotation. Okay? Lowercase, you can see the lowercase. Here it was this. It was this capital letter T. Here is lowercase. Here is uppercase. Here is lowercase. And then this was also dropped. So it's basically lowercasing. So this is uppercase and it's going to lowercase. And then punctuation remover. How do you remove? You eliminate non-informative symbols. Hello world. This is a very common. You all did Python programming yesterday. You wrote your first program, hello world. And when you wrote that program, hello world, there is a command here, hello world. How do you remove it? We have punctuation remover. So you remove this comma and it becomes hello world. You also remove all this slash and this, you remove everything that are symbols, you remove everything and it becomes this. And then also stop word remover, remove common filler words. Where are common filler words here? This is a pen. It's just pen. What are the filler words here? Who can make, type in the comment box, what are the filler words? Filler words in that text. This is a pen. This is a. Those are the filler words. So when we say stop word remover in text preprocessing, we mean removing common filler words like this is a, and it becomes just a pen. And then we have lemmatization and stemming. What it does is it reduces words to base or root form, like running / run. Becomes just run, because that is a root word. The root word is just run. So preprocessing reduces noise and standardizes text to effective NLP modeling. For you to be able to process your data and train your model, you have to remove all the noise. All this that we are doing, we are removing noise. All these symbols that we're removing, all these filler words, all this that we're removing, we are removing noise. We call them noise in our data. If you understand this, type a plus in the comment box. If you don't understand, type a minus, and then we'll move on. I understand this slide, type a plus. I don't understand, type a minus. It seems there is a full understanding. Let's move on there. So here, I would not be talking much about this, but I also want to bring to your attention that we have text representation in NLP. We are starting from the basics and we are going to the highest. And what text representation means is converting text into numbers for machine learning models. There is a way machine learning models understands data. Roland spoke about converting categorical data into numerical variables, where your model can be able to understand what has been fed into. So if you have if you have natural language, like this is a boy, and you don't convert that to numerical values, your model will not understand this is a boy. What the model understands is only numbers. So we have to convert it back to numbers. And what we are doing here, I gave an example. We have different methods of doing that, of converting it. We have one hot encode. Maybe Roland spoke about one hot encode in deep learning. That's one of the most popular way of converting from, say, categorical data or any form of data, maybe true or false, and all those kind of data to numerical data, to ones and zeros. One hot encode. So ones and zeros, and it's able to do that. But going down to NLP, we have more methods of converting text to numbers. And one of them is bag of words. Bag of words does about frequency, it's about frequency based. So it ignores context. And what it does is, if you have something like NLP is fun, what it's going to treat is going to treat this as NLP. Just NLP is fun, NLP. NLP is D1. This is a single sentence. NLP is 1. This is a single sentence. NLP is still in that sentence. Is still in that sentence. Fun is still in that sentence. So it treats it as 1 instead of treating this as 1, 2, 3. It treats it as 1. If you understand, put a plus in the comment box. If you don't understand, put a minus. If you have a contrary view, type in the comment box. Now we have TF and IDF, and here I spoke about TF and IDF. I won't be talking much about this, but TF stands for term frequency and IDF stands for inverse document frequency. And what it does is it highlights important rare words and it reduces weight for common words. So I gave an example here and you can look over it. Because of time, we won't be able to go into this, but this is self-explanatory. And we have word embeddings, which is I'm just touching on the most important ones that we use on day-to-day basis. Like we touch on word to vec on a day-to-day basis. And what it does is, word embeddings, what it does is it condenses vectors, it converts these words into dense vectors and captures semantic similarities. So it converts, when we talk about vectors, what do we mean? Dense vectors. For those who are coming from other non-STEM background, what do we mean? Type in the comment box. What do we mean when we talk about dense vectors or just a vector? A vector A vector means what? Does it mean numbers? Does it mean values? Does it mean what? When we talk about vectors, what are other names of vectors? Vector mean what? Is it values? Is it numbers? I don't know. Can you explain it to us? Just type in the comment box. And just for the attendance, if you are not able to, because we have a couple of questions there, if you're not able to take the attendance at this point, just hold on. And when we run over this, you will be able to have more insights and fill the attendance form. But yeah, we have a lot of things we'll be discussing here, and they will become more familiar to you to be able to take the attendance, because for some of the questions, you may not be able to attempt them if we don't run over these slides. So I'm still waiting for your response. What do we mean by a vector? Vector. Vector means what? Vector, is it numbers? Is it values? Oh. Do we have experts here? Do we have statisticians here? Teach us, those of us who are coming from biochemistry. Okay, values. Someone is saying values. Yes, we're waiting for your responses. And remember, all our admins are taking note of your participation to add to your participation points. So if you miss any of the sessions, this will add up to your attendance and participation. Arrows, directions. Okay, arrows and directions. Okay. We use it in R. Values with directions. Okay, values with directions. Okay, values. So simply, we are talking about numbers. Just values, just ones, just zeros. So king, so dense vectors, okay, let's say king and man. King is directly related to man. Word embeddings, world to vector. King is connected to man. Well, when I spoke about vector, and don't mix it up with world embeddings, the explanation is a little bit different, but I just wanted you to know that when we call vectors, because sometimes to say vector, what is vector? You know, some people don't know what a vector means, and they may confuse vector to maybe a vector mean maybe letters or something, you know. Then when we talk about woman, it's equivalent to being like a queen, you know. So it connects to woman to queen, but you can't connect king to woman. A woman is not a king. A woman is a queen, you know. So, and then we have contextual embeddings, and we have and under that we have BALT and GPT. What it does is the word meaning depends on surrounding text. Word meaning depends on surrounding text. It is powerful for deep learning understanding. We'll not be talking much about that, but as you move into that, you'll be using more of world embeddings, most in particular world to vec and all this other context, and you will get to learn more. But I'll move to these other slides and tokenization. How do we tokenize? And what is tokenization? In natural language processing, tokenization simply means you all have gotten token from a bank. A bank gives you a token. You collect a token from a bank. When we talk about token, we're not talking about a token of money. That small device that they give you, a token, that you can be able to do large transactions. Like maybe if you want to transfer maybe $1 million or maybe $1 million naira, you may not be able to transfer it at some point, and you need a token. I have a token from First Bank of Nigeria, and I use it when I want to do some transactions. So you must have heard about token before, but in natural language processing, what it means is an individual unit of text, such as a word, punctuation mark, or subword segment used for modeling processing. I will give an example here. You have white spaces here. I went to New York to play football. So what are the tokens in this world? The tokens are each unit in this sentence. Each unit in this sentence, I went to New York to play football. I is a token. So when we talk about token, no, I is a token. You split this world into different tokens. I is a token, went is a token, to is a token, New York is a token, to is a token, play is a token, football is a token. So how many tokens do we have on this? I went to New York to play football. Type in the comment box. Let me know if you follow. I went to play football. I went to New York to play football. How many tokens do we have? 7 tokens. That's nice. But it doesn't have, and when we add the start and the end token, how many tokens are we going to have on that word? Let me know. Let me know whether you follow. We have 7 tokens, and all of you have gotten it that we have 7 tokens. What if we add the start token and the end token? How many tokens are we going to have on that? 9, I'm seeing 9, I'm seeing 8, I'm seeing 9. Start, end, plus the 7 you have makes it 9. Start, and then you have that, and then you have 9. And we have another thing like the batch. We have batch. I've done that, and I do it in my work. But because for this class, I won't be going. When you add the batch, then it makes it maybe 10. But always know that we have a start token and we have an end token. You have like maybe, and here you can see who can tell me type in the comment box, what is the start token in this sentence? I went to New York to play soccer. What is the start token and what is the end token? Soccer, 9, 1, and I, keep it coming. I, remember, I is a token of its own. I, no, there is something you are missing. Start and end token, who will tell us? Remember, I went to New York to play soccer. It's a token of, each of that is a token. Quotation mark, you got it. The quotation mark is a start token. Look at the start token and look at the end token. It's under quote. So when counting it, you take into cognizance the whole sentence, everything that is there. So that's why I asked you, how many tokens do we have here? We have 7. But when you count the start at the end, then you have what? 10. But then when you move in, we have some other things like the batch, but I won't talk about that. I'll just talk about the very basic that you need to know. That on this, just know that we have 9 tokens for this. I went to New York to play soccer. All right. So, and then we have embeddings. And embeddings is to convert text into numerical vectors that capture semantic meaning. It captures information, insights, patterns that you may not know. So what embeddings, when you hear about embeddings, what it means is just converting text to what? Numerical vectors. Numerical vectors. Numerical is values. Just converting text to what? Numbers. It's as simple as that. Embeddings. Converting this to numbers. Converting this to this. So when you tokenize to this, and you, I would talk more about that, but those are the tokens, and the representation of the tokens. You can represent it as 1, 2, 3, 4, 5, 6, 7, and all that. But we have different ways of representing them. But for the sake of this class, I just wanted you to understand what tokenization and embeddings mean. If you follow this slide, type a plus. If you don't follow, type a minus. If you have a question, type in the comment box, and then we'll move on. I understand tokenization. I never understood it, but now I understand what tokenization means. I understand what embeddings mean. We have more plus, we have a lot of plus, and that is what tokenization means. You break up a world. What it simply means is splitting. You can say the process of splitting a text object into smaller units. You are just breaking up a text. And where is the text you are breaking? This text You are breaking it into smaller units, such as words, numbers, symbols, engrams, characters, and a lot of things. And here I just show you an example. We have another example here, a regular expression tokenizer. Here you are tokenizing white spaces. It's just white spaces. White spaces, just the white spaces that you are splitting. You can see New York stood on its own because there's no space here between New and York. They are all together. There is no white space. And that's why New York stood as a token. But when you talk about regular expression tokenizer, like football, cricket, golf, tennis, you can see that football is going to stand as a token, and cricket and golf and tennis. So these are the tokens we have for that. And since you all understand, we move on because we still have a lot of slides to cover and our time is running so fast. So I will talk about more on tokenization, types of tokenization. I spoke about them a little bit in the other slide. We have well-level tokenization, like NLP is fun. NLP is fun. So if you want to tokenize NLP is fun, what are you simply doing? You are breaking up this into words. That is what they call word level, word level. Word level is you are breaking it based on words. NLP is a word, is a word, fun is a word. So you are breaking up this sentence based on what? Word. So it's going to be NLP as a single token. Is going to be a token. Fun is going to be a token. So you can see it becomes NLP is a token, is a token, and fun is a token. So how many tokens do we have in this sentence? NLP is fun. Type in the comment box. NLP 3. That's nice. That's nice. Then when you add the start and the end token, how many tokens do we have? When you add the start and the end token, how many tokens do we have? 5. That's nice. You are all good students. Nice. 5 tokens we have. Word tokens. We're splitting up this word into how many? Breaking it into 3. Each word stands on its own. Word embeddings. You can see here, these two are connected. Statistics and math. Math and statistics, they are connected. Mathematics is similar to statistics. You can see, mathematics is similar to statistics. You are breaking the main things in this sentence, the main things in word embeddings, the main things is mathematics and statistics. And these stood on their own. And here we have tiger is similar to lion. Tiger is similar to lion. And we have tiger and lion standing on their own. Tiger is similar to lion. Tiger and lion. So we have 2 tokens, tiger and lion. Tiger and lion. So subword level embeddings like byte pair encoding. We have byte pair. Well, some call it byte pair embedding. Some call it bit pair. Bit pair or byte pair encoding. I call it byte pair. Sometimes when people call it bit, I also call it bit. But byte pair encoding is called BPE. So it's another type of tokenization. And what it does is maybe you will add me some time and I will be able to finish because we need to do this. It's going to be very helpful for you to step your leg in NLP and really understand the fundamentals. So when you talk about subword level tokenization, we are talking about something like handling rare or compound words. Handling rare or compound words. And we have an example here on happiness. On happiness. On happiness. On happiness. And when I say unhappiness, in English, what does that mean? Unhappiness. What does that mean? What is that term in English? Unhappy. unhappiness, unhappiness, syllable, okay, syllable, okay, syllable. Now you understand that NLP is deeply connected with linguistic. So we're studying English. So now on happiness, you break it based on that level, on is a sub level. You can see sub level. Sub level is on happiness is a single word, but we have to break it into sub levels based on what? Syllable. Syllable. And the syllable here is unhappiness. So it becomes how many tokens? How many tokens on happiness? Type in the comment box how many tokens? 3 tokens. When you add the start and the end token, how many? 5 tokens. Nice. You're all good students. So we are all done with sub-level tokenization. You split a word. You split a word into sub-words based on what? Syllable. Based on syllable. So we did that, and we splitted unhappiness into unhappiness. It becomes unhappy and nurse. And each stood on their own. Each stood on their own. Unhappiness. And becomes 3. And then when you add the start and the end tokens, it becomes 5. Then we have sentence level tokenization. You tokenize a sentence. For instance, we have an example here, like NLP is fun. It powers chatbots. NLP is fun. NLP is fun. It powers chatbots. NLP is fun. It powers chatbots. So who determines the number of tokens? Oh my God, someone is trying to write on the screen. Please, if you can try as much as possible to avoid writing on the screen, that would be very helpful. I forgot to turn off that feature, and I have to start sharing, however. So where am I? Okay, you can still see my screen. So can you all see my screen? Type in the comment box. Done on mute. Okay, yes, okay, plus. That's nice. So, okay, I was asking you, I think I was on the other slide. I was here. So how many tokens do we have? Sentence level. Here we have NLP is fun. It empowers chatbots. So how many tokens do we have on this sentence? How many tokens? Let's see. 2 sentence token. Nice. NLP is fun. It's 1 sentence. It empowers chatbots. It's another sentence. So we have 2 tokens. And when you add the start and the end tokens, we have how many tokens? 4 tokens. If you understand this slide, type a plus in the comment box. If you don't understand, type a minus. If you have a question, drop in the comment box, and we will all understand. Now you see AI is easy. You are learning high-level AI topics, and this is very easy. This is very, very easy. So I'm going to go back to the next slide, the popular NLP tasks. And the popular NLP tasks are text classification. Roland already spoke about spam versus not spam. And that's to sort text into categories. For instance, you have spam versus not spam. You have sentiment analysis. You are used to saying this person is sentimental. It's maybe a tribal, it's a tribal sentiment or something. Or maybe he has sentiments for this, you know? Or maybe he has sentiments for, maybe some science students have some sentiments, or some art students have some sentiments, or this person has sentiments, you know? So sentiments, it could be positive or negative. Positive sentiments or negative. Positive, it could be, oh, sentiment, my sentiment. Someone can say my sentiment is that I love coding. Someone can say my sentiment is I hate bananas. But me, I love bananas because maybe that is my sentiment. People commonly say that, so you are doing that. So it's used in text classification. It's also applied in named entity recognition. What it does is that it usually identify and classify entities like names, dates, locations in text. You have an example here. Apple was founded by Steve Jobs in 1976. So what it does is it identifies and classifies this into different entities, different entities like names, dates, locations, and all that. So it's going to run over this text, run over this sentence. It's going to identify, what does apple means? Is he a fruit? No. It's going to say no. It's going to take the whole sentence and analyze it and say, no, the apple they are talking about here is not a fruit. It's a company. And that stands for an organization. So this apple is an organization. And this Steve is a person. This Steve Jobs is a person. And 1976 is date. So he's able to analyze and identify the key entities in this sentence. And also is able to, we use it in machine translation. So like it automatically translates text from one language to another. So when we talk about machine translation, it's like just you using Google Translate. Google Translate is one of the common examples for those of you traveling to Russia. You are using Google Translate to translate Russian to English, translating English to French, French to English. So when we talk about machine translation, that is what it means. It's able to understand how to translate one language to another. And then that's one area of application. And also in summarization, you have like a paper, like a research paper, or maybe you want to read a newspaper. You just feed it into ChatGPT, and it's able to summarize everything for you. You have a concise version of a longer text. So here we have what we call as extractive. It selects important sentences, and abstractive. Abstractives generate novel condensed versions. Novel condensed version. When we generate novel condensed version, we call it abstractive. You abstract. You are abstracting novel points or version of that long text. And extractive, you are extracting important sentences. And here I give an example, newspaper. You can just, like newspaper headline. Newspaper headline. You can just extract the headline just from a newspaper. And then we have question answering, extract or generate answers from a given text. Who found April? Like you just ask question answering. You all are used to this on ChatGPT. It's able to extract your question and generate answers for you. You ask ChatGPT who founded Apple, and then it's able to generate an answer, Steve Jobs. He was the one that founded Apple. If you understand this slide, type a plus. If you don't understand, type a minus, and we'll be able to close. We'll be able to run over the other slides and quickly close. And I hope you will spare us some few minutes. If you're understanding and you want us to extend the time a little bit to cover the remaining parts, type a plus. If you want us to just close now, type a minus. Okay, plus, 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 oh, plus, 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 triple, plus to infinity. Okay, we have, all right, we'll try as much as possible not to go beyond time so much. We'll close very soon. We'll take just a few more minutes to run over this. So we have large language models. And what large language models does is they are being trained on large data. And they are models that are big. They are trained on large data. And one of the examples is an N-gram model. It predicts next word based on N1 previous. It predicts, for instance, For instance, Apple was founded by, because you put Apple and you put founded, it's going to know, oh, the apple you are talking about is not a fruit. It was founded. It means it must be a company. It must be something. So it's not going to predict who founded Apple. So it's going to predict the next thing. So if you just type on ChatGPT, Apple was founded by, let's see what ChatGPT is going to give you. It's going to give you Steve Jobs because of the former context. It takes into cognizance the previous word and is able to predict the next. And that has applications in biology. For instance, you want to predict a mutation. There was a mutation here. What was the exact amino acid that was supposed to be there? If it knows a particular sequence, is able to predict that particular amino acid that is supposed to be at that position. Also, neural language models, like we have neural language models like RNN. We've talked about RNN before, recurrent neural networks, long short-term memories, but they all have limitations, and that's why we have transformers. Transformers came to overcome the limitations of RNNs and short-term memories because of their diminishing gradient. We won't go much into that, but transformers came to overcome some of the challenges and some of the problems that these other models have. Transformer models, that's what I just spoke about, is self-attention based, is able to focus on a specific word. For instance, you want to build a drug, but your drug has to have some properties. Your drug should be able to travel from your mouth to your stomach. You have to give that drug some properties. Your drug should be able to generate some drugs that are soluble. Your drugs should be able to generate some drugs that can be able to bind to a particular disease and give you some relief. So it focuses on the most important parts in a sentence. For instance, Steve knew Apple was founded by Steve. The most important things there is Apple. Steve Jobs was founded in which year? Those are the only three most important key points. So it's going to focus on the only most important things there. And then we also have examples there. We have encoder. Encoder is just the input. The decoder is the output. So whenever you see encoder, encode, enter, decode, leave, let me put it in layman's understanding. Encoder is taking something and it's transforming it into a language that the model understands, and then it's giving you an output, and that output is called a decoder. You are able to decode something. You're able to give an output. And we have some models that are only encoder based, but are only encoder based. And when we talk about encoder based, we mean encoder based. We mean they are based on representation. I think we have it somewhere. Understanding context. They are based on representation. It represents text or it represents things. But when we talk about decoder, that's things like GPT. It is able to generate fluent text. This is a generative task. But for encoder, it's able to just represent your sentence into a way that you like it. It's not generating anything. It's just representation. For instance, how you arrange a particular word. Like, I may just say, founded Apple by Steve Newborn. No, that's not the right. We have to rearrange it. And that's what encoder does. Is able to understand the text and is able to represent the text. And that's why we call it bidirectional encoder representations from transformers. Bidirectional. It runs from the beginning to the end and from the end to the beginning. And is able to understand and rearrange that and gives you a representation that will be useful for your own task. And then the GPT, you all have GPT, ChatGPT. So when you hear about ChatGPT, what do you mean? What do you understand by GPT? If you don't understand what GPT means, it means generative pre-trained transformer. So today, when you chat with ChatGPT, chat is chat, but GPT, do you understand what it means? It means generative pre-trained model. It's generative because you type something there and it gives you a text. It gives you an answer. That is why we call it generative. It's decoding. It's giving you an answer. Decoder. It's giving you have an expectation. So it's giving you something that you need. And why we call it pre-trained transformer. Pre-trained is because it has been trained. ChatGPT has been trained already on massive data, billions of parameters. Parameters is what we call data. Trained on so much data, billions of data. And in biology, we have models like ESM, evolutionary scale models. We have different ESM models, and they are trained on massive data. And when it's being trained on massive data, it has already learned all these patterns before. So when you type something into ChatGPT, it has already learned. So it has already learned, so it can be able to give you an answer. And that is why we call it generative, because it can generate something it can be able to generate an answer for you from something that has already been trained. So it has a memory. It has a memory. It's able to remember that, oh, I trained this before. That is what we call it pre-trained. It's able to remember that I trained this before. So those guys from ChatGPT, they trained this model before and they released it to you. And what are you doing? You're only doing, so when you look at ChatGPT, what you are doing is you're only doing the generative. You're only looking for the generative part to generate something for you. But the training part has already been done for you. We also have T5. T5 is a text-to-text, text-to-text transfer transformer. T5, how many T's do we have here? When we say T5, is how many T's do we have here? 5. 1, 2, 3, 4, 5. The first letter T's. So T5 stands for text-to-text transfer transformer. Text-to-text transfer transformer. So it starts from the encoder and it ends with a decoder. You give an input and you are expecting an output. You are not training from this. You are not doing as you are doing. You are dealing with ChatGPT. You are training from scratch. You are using your own data and you are feeding it into an AI model, and that is giving you an output. So it has a unified format for all tasks where you give an input and it gives you an output. If you understand this slide, type a plus in the comment box. If you don't understand, type a minus. I understand, type a plus. I don't understand, type a minus. Can you see we are doing high level AI or machine learning science, but it's very easy because this is very easy because it's natural language. There are things we relate with on a daily basis. From here, I will move to the next slide, and Bro Abasiam, I hope, type in the comment box how many minutes you are still giving me so I can quickly run over and I will know how many minutes you are still giving me to cover this so we don't run into too much time after this. We have generative AI and attention mechanism. Generative AI and attention mechanism. Okay, parameters and hyperparameters. Okay, that is based in a model that is still in Roland's part, but we have parameters and we have hyperparameters. Parameters and hyperparameters. Parameters are just like your data. Hyperparameters are things you do to improve your model. You feed a data into a model. That is parameters. But Okay, T5. We have examples here. If time permits us, okay, 30 minutes. We have 30 minutes. I think we should be able to run up to that point. So you asked about hyperparameters. So hyperparameters, hyper. You see, hyper. You want to improve the training on your parameters, on your data. And we have different hyperparameter methods. And I think Roland must have touched on different hyperparameter methods. If you type the types of hyperparameters we have, what types of hyperparameters do we have? Type in the comment box. Let's see. Hyperparameters. Do you know any hyperparameter? Type in the comment box. Hyperparameters. Type in the comment box. Regularization, nice. Any other one? They are so very easy ones. This one is the most recent ones. This one is a game-changing ones. Drop out, okay? Drop out. But we have very, very, very easy ones. Let me see if people will get it. Do you know any hyperparameters? Less than 1 minute, and we'll move on. And this is in addition. Please, admins, the committee, the other people, be taking note of the additional points. Early stopping, okay. Early stopping, optimize hyperparameters, okay. What about Adam optimizer? Is it an optimization algorithm? Is it a hyperparameter? And if I'm mixing it up, let me know. But what about Adam optimizer? All right, so let's move on. Generative AI and attention mechanism. So generative AI models like transformers, autoencoders, and diffusion models, they all possess encoder and a decoder. And I told you earlier that a decoder, what it does is it processes input data into context-rich representation. And we already dealt with this on the past slide, on this slide, into rich representations. And then what it does is, after preparing this data into context-rich representation, it now feeds that data. Remember, that data is no longer text, but it's now vectors, it's now numbers, it's now values, it's now zeros and ones. You can use hot encode, you can use other methods that we just spoke about, embeddings. And then you feed that into your decoder. And your decoder uses this representation to generate the output. So the decoder doesn't deal with any representation. It only handles the input you give it. You either give it embeddings, or you give it some sort of vectors that you created based on one hot encode, or from other encoding approaches. We call it encoding methods. You can encode from different methods. And in bioinformatics, we call it K-mass. K-mass. How many representations will you have for this particular sequence? How many representations? So it is able to calculate how many representations you can have, K-mass. And you can be able to calculate the K-mass size. But I won't go into all that, but that's part of the bioinformatics. But this is just one of it. So generative AI methods include generative adversarial networks. You must have heard about this or not. But for sake of time, we'll have something on that. But we also have variational autoencoders. We have diffusion models. We have transformer-based language models. And then we also have autoregressive models. These are the models we have when you talk about generative AI models. All this we're going to be touching very soon. So in 2017, there was a paper that came out about attention mechanism, that attention is all you need. Attention is all you need. So when you are training a model, you want the model to focus on only the most important parts. And I give an example. Apple was founded by Steve Jobs in 1979. So it's going to focus on the most important parts. Apple, the name of the founder, and the year in which it was founded. Those are the three most important information. It's going to focus only on that part. And that is what we call attention mechanism. So let's run over this attention mechanism. This is the attention mechanism. This is a transformer architecture, a standard transformer architecture. So when you look at this is a standard transformer architecture. It's a complex architecture, but what it has is just an encoder and a decoder. You feed your data here. This is your input data. Because your input data, it misses its positions. So the positions it chops off the positions. It's just like in biology, you have the 5' to 3' sequence. You have like an amino acid sequence. It starts from here, it ends from here. On a sentence, it starts from the beginning to the end. And you may remember I asked you about the quotes, the quotation marks. Those are the start and the end. So when you are doing the embeddings, when you are converting to a vector, it loses its position. It loses its start and the end, its start and the end data. It loses it. So when it loses that, you have to encode it again. And that is what we call positional encoding. You encode it to ensure so that your model understands and you can be able to do some sort of like downstream analysis after you train your model. So you feed it into this, and then you get your data from after doing your pre-processing and getting your input embeddings. This is your input data. You feed into this input embeddings, and then you get your positional embeddings. You get multi-head attention. I won't be going much into this and all this, but multi-head attention, I told you earlier that it's going to focus only on the most important parts. You can focus, the attention mechanism can be in both the encoder and the decoder. Focus, you can decide to say, let the attention be focused only on certain parts, and then let the decoder take attention on other parts, or let both take attention on the same parts. For instance, if I'm training a model and I want to build a drug to treat a particular disease, I would like that drug to have some physicochemical properties like what? To have some physicochemical properties like solubility, and to have also binding affinity and even other chemical properties. So I'm going to define those in this. I'm going to ask my model to focus on the most important things. And then we have the add and normalization. I won't be explaining all this. We have the feed forward, and then we have the feed forward. We also have, you have to add another normalization. You have to, you do another add and normalize, and all this, and then you feed this into your decoder. So your decoder, you can see you have your decoder here. And what it does is you have another multi-head attention in the decoder. You can see we have it both at the encoder and also in the decoder. We have another add and normalization. I won't be explaining all this. Feed forward, Roland has already explained this, and also Roland actually explained normalization as well. But because of time, because we still have just very few minutes, then it also converts it into a linear representation. And we have some functions that actually does that. And then we have the softmax layer. We have the output probabilities. And we also have here I mentioned that we have positional encoding. That's after you finish from here, you are feeding your output embedding. The output embedding is from here. After you feed all this input embedding and you come to this level, you are going back. The output you have from your encoder is going to enter into your decoder, and that is what we call the output. The outputs from we call it the encoder. The encoder output, the encoder input, encoder input, decoder input. So you are bringing this input and you are creating you are feeding it into your model and you are training it. So I won't be going much into that, but this is a pipeline, and I'll quickly run over this, and then I have I think 2 more slides, and then we'll call it it off from there. So for generative AI, we actually have some architectures. We have conditional variational autoencoders. I told you earlier that you can condition your model on the most important parts. And we have a variational autoencoder. What it does is it has both an encoder and also a decoder. That is, it takes an input and gives you an output. It maps an input to a latent space. We have a latent representation, and I think in the next slide, I'll be talking about this latent representation. This is an encoder. You have an input image, and you are trying to compress it. You are trying to reduce their dimension into a latent space, and we call this a Z space. This is a latent representation. This is an encoder. This is a bottleneck. This is a latent space, and after you compress it, you reduce the dimension, then you can now feed it into your decoder. And then you have a reconstructed image. The reconstructed image looks like this. It's not the exact one, but it looks like this. It's just like, let me give an example. We have naturally occurring substances, but we can generate new drugs that are synthetic. And that's what I do. So we have naturally occurring compounds like peptides, and we feed them into our model, and it's able to generate synthetic peptides, synthetic drugs that you take, you buy from the pharmacy. So this is it, and the time is okay. Okay, so I just explained autoencoders, and I will be going back to this slide, and then I will briefly talk about VAE, variational autoencoder. It also has an encoder and a decoder, and here I mentioned it maps input to a latent space, then it generates a conditioned output from the input. So the difference between an ordinary VAE and a CVAE is this one has a condition. You have some conditions in mind. If it doesn't have this condition, don't do it. But VAE doesn't have a condition. It's what you give it that is going to give an output. It maps an input and maps an input into a latent space, that's a Z space, and it's able to reconstruct your input data and gives you an original input. It's able to give you a reconstructed output. We have GANs, Generative Adversarial Network, I told you earlier. It doesn't have an encoder, but it does have a decoder. So what it does is it's just for generative tasks, and that is why it's also used in drug discovery. It trains a generator. What it does is just generate. It's just a generator. So it trains a generator to produce samples that fool a discriminator. So it's a discriminative algorithm. So it trains a sample, and it's able to discriminate and fool the discriminator to feel, oh, this was what I expected, and then is able to get the desired outcome. I won't be spending much time on this, but we also have diffusion models. Diffusion models is based on noise. It has an encoder. It does have an encoder. We have the forward and the backward diffusion model. And the forward diffusion model, what you do is you introduce a noise. You introduce Gaussian noise, And when you move on, you learn all what Gaussian noise means. It's a normal distribution actually. And you learn, and that's why you can't bypass all these processes. You have to learn statistics because you have to know what Gaussian noise means, Gaussian distribution. That is a normal distribution. It has a bell shape. It has to have a normal distribution. So what it does is you introduce a noise. You introduce noise into a normal data and is able to reverse. You introduce the noise and is able to reverse and gives you an original data. So what it does is it generates data from noise. Generates data from noise by reversing a gradual noising process. That's why we have the forward and we have the backward process. The forward backwards, the forward step, you introduce the noise. The backward, the backward step, you reconstruct it back to where it was before. And that's why we have an encoder and we have a decoder. And also, when you look at diffusion models, it has both an encoder, a latent space, and also a decoder. So a diffusion model doesn't just have a forward process and a reverse process, but it does have an encoder, a latent space, and also a decoder. And then we have transformer-based language models like GPT. I mentioned this earlier. It has an encoder and also has a decoder. It generates output one token at a time in autoregressive manner. Autoregressive, because of time, we won't be going much into that, but it generates token by token. That is word after word or alphabet after alphabet, number by number. Autoregressive, one after another. And ChatGPT was trained based on that. It's an autoregressive model. So when you hear about autoregressive model, one example is ChatGPT. And so because of time, I've already treated this. I'll just go over foundation models and then I will close on this slide. So foundation models are large-scale models that are trained on broad data that can be adapted to a wide range of downstream tasks. You can train your model like ChatGPT was trained on billions of data. Now you are the user of ChatGPT. So ChatGPT is a foundation model because it was trained on massive data, broad data. And because it was trained on massive and broad data, you can be able to adapt it for your own use, for downstream tasks. I'm using it to design drugs. I'm using not ChatGPT, but I'm using other foundation models like ESM. We have foundation models in different disciplines. Like in my own drug discovery, we have ESM, like evolutionary scale models. We have ESM1, we have ESM2, we have ESM3, we have ESM-C. I've used ESM-C, ESM3. Some ESM are for generative tasks, some are for representation, like ESM-C. ESM-C is for representation, ESM3 is for generative tasks. And I use it for my own AI for drug discovery models. So in all disciplines, it's not one model fit all. It's not only ChatGPT that is a foundation model. We have different foundation models in different fields. And I just mentioned one in my own field, which I'm using for my own AI drug discovery. I'm using it for my own downstream tasks. Why? Because I have low data. My data set is very low. The last data set I used were just about 900 data points. I increased it to about 1,000 and maybe 500, but it's still low. So I have to use a foundation model and do what? Fine-tune it with small amounts of task-specific data. I'm trying to build drugs based on these particular compounds. And I'm feeding that because I don't have much. I can be able to fine-tune it on an existing data. Fine-tune means I can just use that model and train it on my own task because they already learned general patterns from pre-training. They have been already pre-trained. So when you do that, it's able to generate those tasks, those novel compounds for you. And it's for all disciplines, and you can actually use that. And also to reduce training cost, instead of training a new model from scratch for every task, you can start a foundation model and fine-tune it, thereby saving a lot of cost, like computational cost. And large language models, large language models is a deep learning model trained on large context corpora to understand and generate human-like language. So I earlier explained that it's trained on large amounts of data, and I gave some metrics here that we use to measure the large language models. Because of time, I won't be able to go much into this, but we have metrics. Just like Roland gave earlier, we have metrics. Roland already discussed accuracy, precision, recall, F1 score, and all that. And we still use these scores in generative task. And I gave this, you can take out time and know what each of these means. If you have like 89% accuracy, what does that mean? And if you have 67% accuracy, what does that mean? Oh, okay, bro, Roland, just 1 minute. And then I'll just round up from there. So now we have all these metrics, and we have some metrics that you can actually measure whether the compounds you generate or your output is good or bad, or it resembles your input or it doesn't resemble. And we have blue score. We have things like a blue score. We have F1 score, FID, like free chain inception distance. We have perplexity score. I've used all these scores, all these 4 scores. And all these scores, they are metrics we use in measuring whether our model does well or not. Perplexity measures uncertainty. The lower the better. You will learn all this. So because of time, I won't go over this, but these are the metrics, and this is very powerful because it's going to help you to dive into natural language processing. So all the slides, you have access to them. And for the last slide, I want to say that this field is revolving. And you can see these are the recent trends in NLP, large language models, prompt engineering and in-context learning, instruction tuning, multimodal NLP. We have responsible MLP. You can go over this and also look at the applications in healthcare, in finance, in customer service, in education, in legal tech. These are applications, and the field keeps revolving and things keep getting better. So all this, you see Gemini, Google Gemini, you see all these models that you are using GPT-4 and all these models. These are all large language models. And I think with this, if you have questions, you can ask, but join us in our annual conference. We are going to be discussing this high-level science that looks so difficult, but when you are within people, you know, everything becomes very easy. And I hope you have gotten something. If you've gotten something on AI for drug discovery, I'm sorry, I'm mentioning my own discipline. If you've gotten something on NLP, on large language models, on generative AI, on foundation models, just type in the comment box a plus. If you understood this class, type a plus. If you have a question, drop in the comment box, and I hand over to Bro Abasama Hope to take over from there. Thank you.
Thank you so much, Bro Joseph. I can see that you were actually beginning to run. That tells us something concerning next time, that our time is becoming very, very limited and in need for an extension, I think, in days, because that's what I'm noting here, that we need more time. Our trainees are getting more interested and they need time. They just want our attention. And this is something we shouldn't take for granted. I want to say well done to you, sir, and to your team. Well done so much for this great work.
Very much.
So I think more plans will be put in place so that next time, instead of maybe going through all of this, we might give a pre-teaching, a pre-lecture, and we could just refer them, say, okay, check our YouTube channel, and then build from there, and then we can continue something like that, so that we could have more time for in-depth questions and all of that. Well done, sir. So at this point, I'll be having to hand over back to you so that you could take us on the closing and final thing. Thank you, sir.
Right. Thank you very much, brother. So for those that are asking for the questions, ask us on the group. Come join our Telegram group. And I think any of the admins, please pull up the links to our platforms and share in the comment box. so they can be able to join. And also our attendance link has been shared. So please take the attendance. All this has been covered here, and the attendance link has been shared for you to take the attendance. But for you to keep connected, stay connected to our platforms, you will learn a lot. Volunteer and join our NELIREF Research and Technology Institute. You will learn a lot because we are doing research, we are learning all this together, and you will be able to also add to, we are writing papers, we are doing all this, and you'll be able to contribute to knowledge as well. So without wasting time, I will also have to highlight that we have an annual conference, and remember, AI and data science tech is one of our key aims and objectives in New Life Research Foundation. So in our annual conference, we focus a lot on that as well. So when you come, we have breakout rooms where humanities, social sciences, and arts, you stay there, you have high caliber people who are doing all this NLP, who are computational linguistics, and they are going to come there to handle that session. And they are doing their PhD, some are in graduate school, and they'll be there to handle. And we have STEM, we have management sciences. They are all doing business analytics. They are all doing big data. We have a lot of people who are doing PhD, who are doing this high-level science. So to stay connected, get involved in this. And also, we are going to send your certificates to you, but that is based on your attendance. So if your attendance and participation is good, we will send you a certificate. We will notify you next week, and we'll send you a Google form to complete, and then we will generate your certificate, and the certificate will be sent to your email. So we generate certificates automatically, and they are sent to your email. So once we are satisfied with your attendance and participation, we will be able to do that. And all the instructors and TAs and the committee, they've been taking note of your participation in the comment box, your asking of questions, your enthusiasm, and they are taking note of everything, or your commitment and all that you've been doing. And they're also taking note of your installations. It's something I don't need to forget. Those that were asking questions, doing the installations and all that, they are taking note of all that. And if you are not able to take attendance for any of the sessions, send us an email, and we will be able to check our records and take a decision with respect to that, and see if that we add to your attendance. Feel free to reach out to us. We are very, very flexible. We are Christians. We are not hard people. We are very flexible, and you can ask us anything on the group, and we'll be able to help you at any point. So with that, I also want to say that all these recordings and the slides will be sent to our GitHub and our YouTube channel in the coming weeks. So you will have all the resources, and we will send you all the links to your email, and you will be able to access all these materials. And to keep learning, stay connected on our Facebook groups. We repost a lot of resources on a weekly basis, and you will be able to find them on our social media platforms. And also for some, we actually send to you before this time. So that's what I have, and I don't know whether I'm missing something, but the feedback form will also be sent to you with your certificate. When we are sending the certificate to you, we'll also send a feedback. Don't forget to complete the feedback form. It will help. We improved this year compared to last year because we took those feedback, the rearrangement. We had it 2 full days this year because we took the feedback last year. Last year, it was not 2 full days. It was 1.5 day. Now, we may shift it to 5 days. Who knows whether next year is going to be 5 days or 3 days. So your feedback is very important. If you receive the certificate of last year, you are still participating this year, you will see on the certificate that we've made improvements. We take your feedback very, very seriously, and we improve on them because we value your feedback, and we know we are serving you as we are doing it unto God. And we know that as you are also giving your feedback to us, you are enhancing God's work. You are enhancing our productivity and our service to God to reach the lost. So as you are doing that, you are helping us, and you're also doing ministry as you complete that form. It's part of the ministry, so we appreciate that. And with that, I'll hand it back to Bro, hope Abasiama to take off from there.
Okay, thank you so much, sir. I think at this point in time, we'll be doing the closing prayer as we leave. Can we just begin to appreciate God for this opportunity He has given to us? It has been a great time. Can you thank God that you have been given a privilege to learn? Oh, so there's a saying that little is much when God is in it. Can you appreciate God and say, Lord, these seeds you have sown through me, these seeds you have given to me. If you've been a TA, an instructor, you can say, Lord, this thing you've given to me an opportunity to teach others. If you are a student, you've attended as a student, as a trainee, can you say, Lord, thank you for what I have received. Thank you because I know it is not in vain. I know you are deliberate. I know there will be a harvest for you. I know it will bring you glory. Can you ask God for grace? Can you ask Him for grace? Can you say, Lord, help me. Give me grace. Give me grace. What I think I know, as I look back at this day today, may I see that you use this to equip me for the future you are planning for me. When I look back, may I see the workings that you have done in my life. May I see. Can you also pray that you will become a channel for more impact, a more global impact? Even as we expand this research foundation, that you will be part of those who will hold the hands of those God will enable to belong to this research foundation. Can you pray and say, Lord, help us, build us, give us idea, give us men, give us men, give us people, give us platform, give us places. The Bible says we shouldn't be ignorant of what the devil plans, his devices. Can you pray and say, Lord, whatever the enemy will shoot at us, may we be well equipped to bring him down. Whatever arrows he will target at us, may we be able to stand against him. As the people of the world will want to fight us or bring things to distract us, Lord, may we find you standing for us. Oh, may we find you standing for us. Can you pray for open doors and say, Lord, we need your open doors in every aspect of resources. We need your blessing. We need your supply. We need your ideas. We need your strength. We need you to open doors, to give us places we never even imagined. Oh God, this is our desire. This is what we are desiring, that you will open for us. Oh God, the stores, the gates to kings, to nations, to places less imagined. Oh God, that you will take us to places we have not even thought of. You will bring to us, oh God, even those treasures of darkness, hidden riches. I find it in my spirit because I know God is doing something. Can we begin to bring our prayers to a close? That none of us that have attended this program this year will die. None of us will lose our life. None of us will become victims of any evil. In the name of Jesus. Can we bring our prayers to a close as I conclude? In Jesus' name.
Amen.
I just feel, Asa, that you need to draw this conclusion.
Oh,
Please
Father, we
conclude the
thank you.
prayers.
Father, we thank you. Lord, we worship you. We exalt your name. We thank you,
We
Lord.
worship you. Oh, we give you praise.
Father, we thank you. We know that that seed that you've sown in our lives, that seed that you've sown in these lives, oh, that Lord, it will germinate, and that Lord is going to bring forth more fruits. That Lord, next year, these ones that we've sown, these ones that you've sown the seeds, that Lord, they will go out there, and that Lord, they will multiply. That Lord, this seed will not end with them. That Lord, this seed will germinate.
Amen.
That Lord, through them, Lord,
Amen.
may we come to know you in the name of Jesus. We ask, oh Lord, that as we go from here, and as we continue as a team, oh Father, we ask that, Lord, you will help us and you will go with us. Lord, we stand strong as a team. We ask, oh Lord, that as we continue on our platforms, as we continue learning in our research, we ask, oh Lord, that you will go with us. You will draw us closer. Lord, you will unite us. Nothing will divide us in the name of Jesus. We ask, oh Lord, that for as many who are coming in contact with us for the first time, and they are desiring, they don't know you, but Lord, there is a hunger, there is a desire on their hearts. We ask, oh Lord, that you will draw them closer to you. Closer to you, Lord, we ask today that these ones will draw them closer to you. That, Lord,
Amen.
the enemy will not steal this gift, this seed that you sown in their lives. Lord, the aim, the goal is to transform, is to set them apart, is to set them apart for your use. We ask, oh Lord, that this will continue with them, that this will go with them. That, Lord, they will not go from here. And that, Lord, they will not be lost in a crowd. But that, Lord, they will stand out for you. And that, Lord, they will do exploits for you. And that, Lord, this seed.
Amen.
That, Lord, generations unborn will benefit from this seed. As they go out there and they take positions in the industry, Lord, they will lay a platform that it's going to raise a stand for God, that the kingdom of darkness will not prevail, that the enemy will not prevail over these lives of God. As for the fact that, Lord, you have been merciful and you've been kind to us. We ask, O Lord, that you will extend your grace and your mercy unto us. For as many that are desiring to know you, we ask, O Lord, that you bring them to this point, that this desire in their hearts, that, Lord, you will bring them to you. Blessed be your name, O Father, because we know that you've answered us. For in Jesus' name we pray. Amen. Amen.
Amen.
Amen. All right. Thank you, everyone, for joining us. Thank you for the summer school. It was such a nice time with you all, and we hope you all benefited from this summer school. This is not all. Just stay connected. More is yet to come. Some of you may even come back next year as instructors or teaching assistants. We're very open to welcoming you, and we look forward that God will go before you and will conquer for you. Thank you so very much and remain blessed.